Okay, so good evening, all of you. Welcome back to the session. So this is the last Abhyas session of XEA Maths, correct? So I hope this week you are completely busy with the PYQs, then Abhyas sessions and all. And finally, we came up for the last session of Abhyas in before GATE XE 2025. Is it? Yeah. Good evening, all of you. Okay, so shall we start the session? So basically, due to certain issue the last time, so we were making it one shot, but of course I'll try to cover maximum possible models in this class and also the topics where we expect most frequent questions. So we'll put more focus on those topics as well. Okay, fine. So just comment in the chat box. Are you all okay with this? Vibhu, Preeti, Mahavir, and of course so many who is online. Okay, so let's start the session. So obviously you have reached the last part. Of course, yesterday this did not happen, but you are at this mathematics last XE Abhyas of GATE 2025. Okay, and this is the Telegram channel. So if you wish, you can seek some guidance from me. You can just scan this. Okay, and now let us, without any further delay, let us start the questions. क्योंकि आज का सेशन थोड़ा लंबा जाने वाला है. So we will solve questions straightforward. Okay. So the first question. So this is first question, and of course during PYQs time I was not able to solve some 2-3 good PYQs. Okay, so मैंने उस questions को भी इसमें include किया था, लेकिन बेसिकली जो क्वेश्चंस होते हैं वो मैक्सिमम 95% ऑफ द क्वेश्चंस जो है इस सेशन में वो नया क्वेश्चंस है. ठीक है, सो चलो लेट्स सॉल्व दिस क्वेश्चन. सॉल्यूशन. A matrix B is equal to a power 8 minus 11 a power 7 minus 4 a power 6 plus a power 5 plus a power 4 minus 11 a cube minus 4 a square plus a plus I. Okay, if A is equal to this particular matrix, then the determinant of the matrix B is dash. Okay, so B is given by this complete combination of matrices. So what would be determinant of B? Okay, so let's see what we can have. So A is equal to, so let me write this, given A is equal to 1, 2, 3, 2, 4, 5, okay, and 3, 5, 6 actually here. Okay, so this is 3, 5, 6. Now, if you see, let us calculate characteristic equation of this equation. Okay, so this implies characteristic equation is lambda cube minus trace. So trace is going to be like 1 plus 4, 5, 5 plus 6, 11. So 11 lambda square plus. Now calculate the principal minus. Okay, so minus of 1 is 4 6 are 24, 24 minus 25 minus 1 plus minus of this 4. So if you delete this one, this column, 6 minus 9 minus 3. Okay, plus minus of this 4 minus 4, it's 0. Good. So this is lambda minus, what is the determinant value? So let's calculate the determinant value. 1 times of 24 minus 25 minus 1 minus 2 times of 12 minus 15 minus 3 plus 3 times of 10 minus 12, which is minus 2. So this plus 6 and minus 6 gets cancelled. So you have minus 1 is equal to 0. This is the characteristic equation, right? So you can see the characteristic equation is lambda cube minus 11 lambda square minus 4 lambda minus 1 is equal to 0. So this is the characteristic equation. Now in XE syllabus also you have one thing called Cayley-Hamilton theorem. So what is a Cayley-Hamilton theorem? Every matrix satisfies its own characteristic equation, correct? So by Cayley-Hamilton theorem, you can see by Cayley-Hamilton theorem, so what does this theorem tell you? Every matrix satisfies its own characteristic equation, correct? So this implies, so if this is lambda, then instead of lambda, if you replace A, this equation should get satisfied. So A cube minus 11a square minus 11a square minus 4a minus 4a, okay, minus 4a minus 1, so that is minus I is equal to 0. This is a null matrix, correct? This is what you have. Now let us see what is B. So therefore, given B is equal to, so let's do something. From this first 4 terms, you take a power 5 common, okay? So if you take a power 5 common here, you will get a power 5 times of, then a cube minus 11a square, a cube minus 11a square, then this is minus 4a plus I, minus 4a plus I actually, okay? So this is plus 1, is it? Minus, plus, minus. So this is minus of minus 1. So this should be plus 1 actually. So this should be plus 1, correct. Okay. This should be minus of this minus 1. Minus 1 is the determinant value. So minus of minus 1. Okay. So I have missed the plus sign. So you should be very careful here. So this is plus 1 because minus of minus 1. Okay. Because determinant is minus 1, not plus 1. So this I plus, then from this next 4 terms, again you take a square common. So plus a square times of a cube minus 11 a square. Okay, so 11 a square. Just a second. I think we have taken the first 4 terms. So here you take only a common, not a square. So a times of a cube minus 11a square minus 4a plus I plus, then what's the last term? You have plus I, that's all. Okay, so plus identity matrix. But now since this matrix satisfies the characteristic equation, this value is a null matrix and this value is also a null matrix. So this gives you B is exactly same as identity matrix. Okay, so therefore determinant of B is equal to 1 is the actual answer in this case. Okay, so that B is equal to 1 is what you get. Clear to all of you? Is this okay? It's a good question, right? You can see the common factors and where this combination becomes 0 actually. Clear? Yes? Are you all okay with this question? So maths nahi aa raha mujhe. Should I skip? Don't skip. Okay, because I'll tell you something. Normally if you look at the technical subjects, majority people will do. Okay, so maximum like 5-6 marks difference, everybody would do this, but not in the case of maths. Okay, maths could act as one of the biggest deciding factors in XE at least. Okay, rank of a plus b equal to rank a plus rank b. No, it's wrong. Okay, because like for example, you take this matrix. I'll show you one matrix. Okay, so A is equal to 1 1 1 0 0 0 1 0 0 0 1. So you know rank of A is equal to 3. Okay, similarly let's say B is equal to minus 1 0 0 0 minus 1 0 0 0 minus 1. Here also you know rank of B is equal to 3, but you know A plus B gives you a null matrix, correct? So rank of A plus B is equal to 0 in this case. Okay, and 0 not equal to 6. Okay, so that's why you should not look at these things. Fine. And V bug, please don't leave maths. Okay, because in XE maths acts as one of the biggest deciding factors. Okay, because technical subjects more or less everybody get the same marks. Fine. So anyway, for this question the answer is 1. Option C is the correct answer. But in general, you know, if someone has asked me, hush, this is the way. Okay, chalo, let's go to the next question quickly. So let's solve this MCQ. Limit n tends to infinity 1 by 1 minus n square plus 2 by 1 minus n square and so on plus n by 1 minus n square obviously. What should I do now in this situation, sir? Maths में क्या पढ़ना चाहिए अब? मैट्रिक्स आता है सिर्फ. जस्ट लुक एट द PYQ सेशंस. ओके, क्योंकि उस क्वेश्चन सॉल्व करने में जो टेक्निक्स मैंने यूज किया था उसी टेक्निक्स के अनुसार मतलब अगर क्वेश्चन आया तो थोड़ा सा एडवांटेज मिलेगा. ठीक है, सो देन लेट्स सॉल्व दिस. इट्स अ वेरी सिंपल क्वेश्चन ऑफ कोर्स. सो लेट anybody could do this question. Limit n tends to infinity summation I is equal to 1 to n I by 1 minus I square. Okay, so this is what, no, it is 1 minus n square. Directly it's given. Okay, fine. So 1 by n minus n square. So this summation is with respect to I. If you take this 1 minus n square common, so L is equal to limit n tends to infinity. Since this summation is only with respect to I, you take this 1 by 1 minus n square out. Then summation I is equal to 1 to n I is what we have. So if you add 1 plus 2 plus 3 plus 4 and so on, you'll get sum of n natural numbers. So L is equal to limit n tends to infinity n times of n plus 1 by 2 times of 1 minus n square obviously. So you know this can be written as limit n tends to infinity n square plus n by minus 2n square plus 2. And clearly these two polynomials are of same degree, so answer is minus 1 by 2. That's all. Because when these polynomials are of same degree, the ratio of these leading coefficients 1 and minus 2, this ratio is actually the answer. So minus 1 by 2 should be the correct answer in this case. Okay, so minus 1 by 2, option B is the correct answer. Okay, if it was n square minus 1, then 1 by 2. But now in this case it's you know, GB होगा का XC का सर नो, एज ऑफ नाउ वी डिडंट प्लान फॉर गेट बिफोर गेट, ओके, बिकॉज ऑलरेडी टाइम बहुत कम है। मैंने सोचा था कि पूरा टीम ने सोचा था कि अभ्यास सेशंस करने में ज़्यादा फायदा होगा, ठीक है। सो -1/2 इज द करेक्ट आंसर, ठीक है, बिकॉज द LCM इज कॉमन, यू कैन टेक 1 - n² कॉमन एंड देन यू कैन वर्क आउट द स्टफ, ओके। इज दिस क्लियर टू ऑल ऑफ यू? काफ़ी आसान क्वेश्चन है। यस और नो, प्लीज टाइप इन द चैट बॉक्स। एंड आज की क्लास में मैं बीच में जो एक्सी का टिप्स होता है normally, because you know I have got an XC ranks like 10, 4, okay, and 40 some 3 years back. So I'll tell you so many techniques which could help you, and they'll make sure that you attempt the paper in a sequential way, okay. So we'll keep sharing this tip at least once after every 1 hour. I'll spend some 5-10 minutes at least on general talk, okay, fine. So chalo, let's solve this. The value of the integral, line integral, cyclic integral over z dx plus zx dy plus xy dz, where c is the curve x square plus y square equal to 1 and z is equal to y square, and it's a closed integral, okay. You see, it's a cyclic integral. Solution: given integral is I is equal to integral over c yz dx plus zx dy plus xy dz, okay. So this is the question. Actually you can solve this question using how to increase speed, better stay slow, okay, because many times स्पीड की वजह से मैं कैलकुलेशन मिस्टेक करता हूँ, सो इसके वजह से ऑल इंडिया 1 भी मिस होता है, मुझे दो बार मिस हो गया ऑलरेडी. सो यू डोंट डू दिस मिस्टेक्स, ओके, बी स्लो एंड स्टडी, ओके, बट कीप मेक श्योर यू maintain focus for the 3 hours continuously, okay. So chalo, now this question actually can apply Stokes theorem to solve this question very easily. Stokes theorem is not officially mentioned in the syllabus, but since line integrals is there, I thought of giving Stokes theorem also, okay, so that it's slightly better to use. So this integration can be written as cyclic integral over c. This can be written as yz I cap zx j cap xy k cap dot dx I cap plus dy j cap plus dz k cap, okay. So then this is something like f, the vector, and this is something like your dr bar, okay. So this is dr bar. So now if you apply the Stokes theorem, this can be written as integral over the region R, which is bounded by this curve, curl f dA is what you can say, okay. But in this case, if you calculate curl, because I know I can see this f can be written as f is equal to gradient of xyz. That's what you have, okay, because you see, if you calculate gradient of xyz, this is what exactly you would get. So this curl f is 0. So this integration is also 0. That's all, okay. So since this is closed path, you can see this, you can apply the Stokes theorem, you can get these values, okay. It's not, Stokes is not official in the syllabus, but since I thought of putting one line integral question in 3D so that it would be advantageous in maximum to maximum case, if they ask this, it could be easy for you to do, okay. Because the tough questions in 2D line integrals we have solved in PYQs, okay. You remember we have solved one questions like there is a path like this, one integral is alpha, beta, c1, c2. We have solved these questions already in this case, okay. But one question for safety I have taught. What approach to follow evaluating XC? How to decide which sections to attempt, sir? It's always better, as I told you, to prepare the subjects well in head, okay. It's okay right now if you have prepared all the 3 subjects, then as soon as you see the question paper, you can open the sections and you can decide. That's one approach. Or else it's always as per my suggestion, if you see, because it's not like one subject becomes very easy and one becomes very tough, so better prepare your subjects well ahead and attempt those subjects, okay. I'll tell you one important point in today's class. See, many students even after the exam they complained me this, okay. Like if you open GATE 2025 website, okay, maybe I'll open a GATE 2025 website for you, okay. So you see GATE 2025 mock test links, GATE 2025 mock test, okay. So if you see mock test links, I'll just want to show you one thing. Many of you don't know how to tick, okay, so that because of this tick in XC you'll lose some marks again, so I don't want you to lose that. So see here, engineering sciences, for example, click here, Okay, so sign in. You might have done all this stuff in your ME exam. So when you are clicking ready to begin, for example, okay, so this is last year's paper, I think. Yeah, last year paper. So now if I open fluid mechanics, for example, okay, and if I am trying to enter the answer, you see no keypad is coming down, correct? Or let's say, for example, if I go to some MCQ kind of question, I was not able to move anywhere, correct? You see, I was not able to move anywhere. I'm typing, but I was not able to move. The reason is many students in exam get this problem, and even the staff or the, basically the invigilators who are coming in the TCSI on digital zones, these guys don't have proper knowledge sometimes, okay? So they feel like some computer was stuck or something, okay? But the timer keeps running here, you can see, okay? The issue is here, if I tick this checkbox, only then everything gets activated, okay? So without ticking this checkbox, if you try to attempt, like for example, if you delete this, okay, so see nothing is happening, okay? People feel that it is stuck, but it's not actually stuck. So you should tick this tick mark, and then similarly, if you want to apply solid mechanics, okay, solid mechanics, whatever, just a second, I should reset one of these. Okay, maybe this button, yeah, here it is. So then only I can keep answering, okay? So please tick the tick and then start answering. Otherwise you won't be able to see the things. Then, so let's solve this question. Then next question. So you can see if e power x, x e power x, x square e power x are the linearly independent solutions of a differential equation, then the differential equation is dash. So here they have given the solutions, okay? E power x, x e power x, x square e power x. So these are the solutions. So which of this is the correct differential equation for which this is the solution? Answer मार्क करने के बाद अनटिक कर दिया तो सब आंसर चले तो नहीं जाएगा ना. Why you should untick? Don't untick, okay? Anywhere. Of course, when you untick, it will ask for you comment. It will ask you for a comment, but don't untick, okay? After solving, don't reset. And after writing every question, you should click save and next, okay? It's not like you solve first question then click on number 2. No. After solving the question, you should click on save and next, okay? Fine. So let's see what are the solutions. Given linearly independent solutions, are e power x, x e power x, and x square e power x, right? Now, one very important thing in subjects to me, answers mark करने के बाद untick कर दिया तो why you should untick? You don't untick it, okay? No need. After you solve that, again you click on whatever the section you like and answer, okay? Then, so let's see. Linearly independent solutions are e power x, x e power x, and x square e power x. Now, if you see, like for example, if phi 1 and phi 2 are two linearly independent solutions, okay? So let's say phi 1 and phi 2 are two linearly independent solutions of a differential equation. Then any linear combination of this, what is the meaning of linear combination? Some constant c1 phi 1 plus c2 phi 2 is also always a solution, correct? Like if you have two linearly independent solutions, then this combination, any combination of that two solutions, I mean the linear combination is also a solution to the DE actually, okay? So then if you see, therefore this implies solution to the DE. Solution to the DE is y is equal to some constant e power x plus c2 into x e power x plus c3 into x square e power x, definitely. So this gives you c1 plus c2x plus c3 x square times e power x. So this is the solution. So if this is the solution, then what would be the roots of the auxiliary equation? If this is the solution, then roots of auxiliary equation. Roots of auxiliary equation are 1, 1, 1. Yes? Yes or no? So roots of the auxiliary equation are going to be 1, 1, 1 actually. So now if you solve this, you'll get, it's a cubic equation, third order equation, y double dash minus sum of the roots 1 plus 1 plus 1. So 3 y double dash plus, okay? Then again, product of these two, 1 plus product of second and last, product of first and third, it's again 1. So y dash minus product of all three, 1 times y is equal to 0. That's all. Because you know, if you have alpha, beta, gamma as the roots, then equation is x cube minus alpha plus beta plus gamma into x square plus alpha beta beta gamma gamma alpha times x minus alpha beta gamma is equal to 0. So this is the equation, and obviously if that's the equation, then the auxiliary equation is m cube minus 3m square plus 3m minus minus 1 is equal to 0. So corresponding dE is this. Okay, so then the correct answer should be y table dash minus 3y double dash. So these options are wrong. Then plus 3y dash, this is correct and this is wrong. So option A is the correct answer, and minus y is equal to 0. It's less like ulta of whatever you do generally. So let's solve this question again. If f of x is a polynomial function such that f of x plus f dash of x plus f double dash plus f triple dash is equal to x cube, and g of x is equal to integral f of x by x cube dx, g of 1 is equal to 1, then g of e is equal to dash. Okay, so that's what. In writing characteristic equation, how to calculate sum of minor diagonal elements if only eigenvalues are known. If only eigenvalues are known, then this is how you calculate, because you know this, and these are the roots of characteristic equation, correct? If you know these three, this is how you form the characteristic equation directly. Okay, without even knowing the matrix. Because if you directly know the characteristic, if you directly know the eigenvalues, then let's say lambda 1, lambda 2, lambda 3, this is how you form the cubic equation. Okay, Devashish, fine. The sum of the minors is calculated using this combination, summation of taking product of two roots at a time. Okay, fine. So let's solve this question. So what is g of e actually? Solution. F of x is a polynomial function, and it's given f of x, f dash, f double dash, f triple dash, and so on is equal to x cube. Now can someone tell me how roots of auxiliary equation are 1, 1, 1? Because if roots are alpha, 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 c1x or c1 plus c2x plus c3, I mean c2x plus c3 x square whole power e power alpha x is the solution of the dE. You know, in since you are from this batch, I know, and we have talked about solution of higher order differential equations, correct? If roots of the auxiliary equation are getting repeated, okay, then this is how you form the solution. You remember? I have taught you this. Yeah, so that's how. So looking at this statement, can someone tell me what is the degree of f of x? F of x का degree कितना होता है? When you add the function, its derivative, second, third derivatives, and so on, you are getting a cubic term. Okay, so if you are getting a cubic term, then what should be the degree of f of x? F of x का degree कितना होता है? Any one of you? Correct? This should be a third degree function. If this is third degree, this will be second, this will be first degree, this will be constant, right? And this summation is equal to x cube. So let's see. Let f of x is equal to ax cube plus bx square plus cx plus d. So this implies f dash of x is 3ax square plus 2bx plus c. F double dash of x is equal to 6ax plus 2b, okay, and f triple dash of x is equal to 6a. That's all. Okay, so you have these things. Now if you add, okay, u face will be changed. I didn't get it. Can you repeat? Mechanical rockstar. So if you add them, okay, so if you add them, let's see what you get. F of x plus f dash of x plus f double dash of x plus f triple dash of x, okay, is equal to, now ax cube plus b plus 3a x square plus c plus 2b plus 6a plus 6a times x plus d plus c plus 2b plus 6a, okay. But now this complete term is equal to x cube, right? So this complete term should be equal to x cube. Then if these two has to be same, then this value of a should be 1 clearly. Then all these terms are zeros, okay? Means the coefficient of x square, coefficient of x, this constant term, these guys are zeros actually. So let's get the values of a, b, c, d. So if you compare, a is 1. So if a is 1, then b should be minus 3. So that minus 3 plus 3 would be 0 actually, okay? Then this term should also be 0. So c plus 2b. So 2b is minus 6. 2b is minus 6 plus 6 times of 1 is 6. It is 0. So c should be 0 definitely. So if c is 0, then 2b plus 6a. So 2 3s are minus 6 plus 6 1s are 6, 0. These two gets cancelled. C is 0. So d should also be 0 actually here. So you have the polynomial as f of x is equal to ax cube plus bx square. This is what you have as the polynomial. Yes? Is this okay to all of you? Did you all understand? The crux in this question is to understand that this f of x is a polynomial of third degree. That's all. If you can understand that, then this will take hardly 1 minute to identify what is this function f of x. Yeah? F of x is equal to this. Okay. Now, they have given one condition. G of x is equal to integral f of x by x cube. So, given g of x is equal to integral f of x by x cube dx. So, this is equal to integral. If you write this function 1 minus 3 by x dx, which gives you x minus 3 ln x plus some constant. Okay. So, g of x is equal to x minus 3 ln x plus some constant. Okay. Now, g of 1 is equal to 1. This g of 1 is equal to 1 is given to get this constant, arbitrary constant. So, g of 1 is equal to 1 implies 1 is equal to 1 minus 3 times ln 1 plus constant. So, this term is 0. 1 gets cancelled. So, this constant is 0. So, g of x is equal to x minus 3 ln x actually here. Okay, that's all. So, then g of e is what they're asking you. So, g of e, what should be g of e? You put x is equal to e in this, e minus 3 times ln e, but this ln e is 1. So, g of e is equal to e minus 3. That's all. Okay. So, g of e is equal to e minus 3. Clear to all of you? It's fine. So, e minus 3. It's a simple question, right? Not a tough question at all. But such kind of questions can come in XC, especially from calculus and all. They'll play with the integrations and all. Okay. Yes? Is this question clear to all of you? Let me have some water. Easy, but may have silly mistakes. हाँ, बिल्कुल. So, see, XC में when you are doing calculations, you should be very careful. Okay? क्योंकि questions आसान नहीं होता है, लेकिन जब calculations करना पड़ेगा, उस time पे काफी mistakes होता है. तो equation arbitrary से तो कर सकते हैं. No, this is not arbitrary. See, I'll tell you the logic. It's a polynomial function. Okay? So, polynomial का general form क्या होता है? F of x is equal to some function ai x power I, let's say. Okay, so a naught x power 0. Okay, I is equal to 0 to n, let's say. For example, this is the polynomial function. Okay, so a naught x power 0, so 1. A naught is a constant. A1x plus a2x square and so on, a n x power n. But when you differentiate a nth degree function, like you can see, if you differentiate a cubic function, you'll get a quadratic function. If you differentiate a quadratic, you'll get linear. If you differentiate linear, you'll get constant. Okay, when you add all these terms, if this has a x cube term in it, then definitely this function should start with x cube term. Yes or no? Mechanical rockstar, did you understand? If I choose any other function, then definitely I won't have x cube here, a polynomial. Okay, if I start with any degree polynomial for f of x, I won't get this x cube. Got it? So this would be the last XC session. Okay, so these are polynomial functions, so you just have it again, that's all. Okay, so chalo, let's solve another question. So e minus 3 is the correct answer anyway. So let's solve this question. If a is equal to aij n by n, where aij is equal to I square minus j square is a square matrix of even order, then which of these is correct? Okay, a is symmetric and that a is a perfect square, maybe. So let's see. So given aij is equal to I square minus j square. Okay, so this implies if you interchange this I and j indices, aji would be j square minus I square. So if you take minus sign common, I square minus j square, and this I square minus j square term is nothing but minus aij. Okay, so aji is equal to minus aij. If this is the case, what is this matrix? Any one of you? In a matrix, if elements are symmetric properly but you have a minus sign, then what is this matrix actually? Any one of you? If aij is equal to minus of aji, it should be मैट्रिक्स का टाइप क्या होगा? सिमेट्रिक, स्क्यू सिमेट्रिक, कुछ तो स्क्यू सिमेट्रिक, करेक्ट? सो दिस इज स्क्यू सिमेट्रिक मैट्रिक्स. A is skew symmetric matrix. ठीक है? So if A is skew symmetric matrix, these two options are wrong. Now obviously people feel that it's option C, लेकिन C नहीं है. ठीक है? क्योंकि this is zero only if this is odd order, not even order. I know आप लोगों में काफी लोग इस स्टेटमेंट को मगअप करते हैं, but this is zero only if the skew matrix is of odd order. ठीक है? जब इवन ऑर्डर होता है डेट जीरो होने की नेसेसिटी नहीं है. क्लियर? लाइक आई विल टेल यू व्हाई. maybe this statement is important actually. If you want to write, you can write determinant of every skew symmetric matrix of odd order is zero. ठीक है? Of odd order is zero. Like for example, जब मान लो कि आपने कुछ skew symmetric matrix लिया था, ठीक है? So skew symmetric, maybe I'll just quickly show you. So skew symmetric implies A is equal to minus A transpose. ठीक है? So मान लो कि इस मैट्रिक्स का साइज n by n है, ठीक है? So this is n by n. So अगर आपने दोनों साइड डिटरमिनेंट लिया तो क्या होगा? Det A is equal to, now this minus 1 is a scalar multiplication. ठीक है? So अगर आप minus 1 कॉमन करना है तो minus 1 whole power n times determinant of A transpose. क्यों? क्योंकि determinant of K times A n by n is equal to K power n times det A. Okay? So ये तो काफी important point है, so इसको भूलना मत. Then determinant of A times determinant of A transpose is same as determinant of A. So then if you take det A common, 1 minus of minus 1 whole power n is equal to 0. ठीक है? And जब n odd होगा, when n is odd, this implies 1 minus minus 1 whole power n is equal to 2. Okay? So 2 times of det A is equal to 0. इसका मतलब यह है कि determinant of A 0 होगा. And this you can confirm only when n is odd. अगर n odd नहीं है, if n is even, then this, if n is even, this term itself will be 0. So 0 into det A is 0. Then there is no necessity that det A should be 0. Okay? So that's why I know many of you will answer C. So just to confuse you, I have given this even. But लेकिन जब even होता है, ये determinant 0 होने का जरूरत नहीं है. ठीक है? So none of this is the correct answer in this case. But just to make this point stress here, I have given this, point actually. Okay? Fine. So this happens only when n is odd. ठीक है? चलो, let's go to next question. Solution. A point is selected at random inside a circle. ठीक है? हमारे पास एक circle है. So in this circle, a point is selected at random. So this is the center, for example, and it is selected at random. The probability that the point that the point is closer to the center of the circle than to its circumference is dash. Okay? That will be perfect square. Where if it's even. Yeah, generally in case of even it can be perfect square. Okay, fine. But generally if it's only the case of 2 by 2. Okay, so chalo, let's solve this. So if you take a point, for example, then what is the probability that a point marked randomly is closer to the center than the circumference? ठीक है, so अब मैं एक लाइन बनना चाहता हूं, ठीक है. Now let's say this distance is r by 2 and this distance is also r by 2. Now if you take the point inside this, definitely the point will be close to the center than the circumference, correct? And अगर point हमने इस annulus में लिया तो then definitely these points which are outside this white circle will be closer to the circumference than to the origin. Yes? Yes or no? Correct? So this is the full area of the circle, but out of this full area, the area which is inside this white circle is only the favorable case, such that the point plotted will be close to origin. Okay? So therefore, for point to be close to the center, it's a काफी आसान question है. So for the point to be close to the center, point should lie inside or on white circle. Okay, inside the white circle. Okay, because on is a favorable case, so inside the white circle. So therefore probability is equal to favorable area by total area. ठीक है, एंड ये होगा पाई r by 2 होल स्क्वायर बाई पाई r स्क्वायर इज द फुल एरिया, बिकॉज आपके पास फुल सर्किल है, सो यू कैन प्लॉट द पॉइंट एनीवेयर. ओके, सो दिस गिव्स यू 1 by 4. इज अ वेरी सिंपल क्वेश्चन बट ज्योमेट्रिकली ए नाइस क्वेश्चन. ओके, सो 0.25 राउंड ऑफ टू 2 डेसिमल्स, क्योंकि एग्जैक्टली 2 डेसिमल्स आता है. ठीक है, एंड एग्जाम में जो जिस क्वेश्चन का आंसर परफेक्टली डेसिमल्स होता है, ऐसे इन दिस केस लाइक 0.25, 0.5, 1, ऐसा परफेक्ट आंसर्स आता है, उस क्वेश्चन को रेंज नहीं देते फाइनल आंसर की में. ठीक है, सो यू शुड बी वेरी केयरफुल. फाइन, लाइक इन दिस केस यू सी आंसर इज एग्जैक्टली 1 by 4. ओके, सो 0.25, सो 0.25 परफेक्टली आ रहे, सो रेंज नहीं देते ऐसे टाइप क्वेश्चन का, सो यू शुड बी लिटिल केयरफुल. ठीक है, सो लेट्स गो टू द नेक्स्ट क्वेश्चन. चलो, एक न्यूटन लेब्निट्ज का आया था सॉल्यूशन. The value of limit h tends to 0 1 by h integral 2 to 2 plus h root of t square plus 2 dt is dash round off to 2 decimal places. Come on, let's solve this. Given limit is L is equal to limit h tends to 0 1 by h integral 2 to 2 plus h root of t square plus 2 dt. ठीक है, now when you put h is equal to 0, so you can write this as limit h tends to 0 integral 2 to 2 plus h root of t square plus 2 dt divided by h. Okay, now when you put h is equal to 0, integral 2 to 2, so कुछ भी function लिखिए, but the integration from same limits will be 0 and h is also 0, so this gives you 0 by 0 form. ठीक है, so this gives you 0 by 0. So you'll apply L'Hospital rule. So by L'Hospital rule, this implies L is equal to, so limit h tends to 0 डिफरेंशिएशन ऑफ एन इंटीग्रेशन. ठीक है, लेकिन डेरिवेटिव किस वेरिएबल के साथ करना है? h के साथ करना है, करेक्ट, बिकॉज द वेरिएबल इज h एक्चुअली. सो इफ यू डिफरेंशिएट दिस फंक्शन, रूट ऑफ 2 plus h whole square plus 2 into derivative of this function with respect to h is 1 minus when you put 2, root of 2 square plus 2 into derivative of 2 is 0 by 1 actually. Okay, so this is 1, derivative of h with respect to h is 1. So then if you substitute the values, 0 into something, it's 0. So if you put h is equal to 0, this gives you square root of 2 plus 0 whole square, so 2 square plus That's all. So 4 plus 2 square root of 6. So round off to 2 decimal places. 2 point कुछ तो आएगा. अच्छा. Let me take the gate calculator. Gate calculator. Okay, 6 square root 2.449. So and 2 decimals तक round off करना पड़ेगा. So 2.45. बस. Okay. So 2.45 should be the correct answer. Okay. So 2 decimals तक round off करना है. So 2.45 is the correct answer. Okay. Yeah, good. काफी लोगों ने अच्छा किए थे. Mechanical, Rockstars, Sharma, Aditya. Are you all understanding these questions? These are good questions. Okay. जब हमने PYQ solve किए थे उस टाइम पे भी ऐसे questions हमने देखा था. And even now we have put some similar, in fact some more complicated questions so that you'll get thoughts in exam hall. Okay. Fine. So 2.45. ठीक है. So let's move forward. The unit normal to the surface. ऐसे questions काफी आते हैं मैकेनिकल में भी सिविल में भी. So let's see. The unit normal to the surface, some surface at the point 2, -2, 3. So अगर circumference की साइड पॉइंट तो हो, probability 0.75 होगा ना, obviously, क्योंकि जब सेंटर से दूर जाते हैं एरिया बढ़ेगा ना. So 0.75 would be the probability point lies close to circumference than to the center. ठीक है. So let's see. Given surface is phi of xyz, let's say, is equal to x square y plus 2xz minus 4. ठीक है. So this is the surface. So for example, this is the surface. Then there is a point on this surface. Point कितना है? 2, -2, 3. So this point will satisfy this equation definitely because this is the point on the surface. So इस point पे unit normal चाहिए. ठीक है. So the unit normal n cap and this is phi of xyz is equal to 0. Let's say this is the surface. So unit normal vector कैसे calculate करते हैं? n cap is nothing but gradient of phi. So gradient of phi normal देगा. Okay, लेकिन unit normal नहीं. ठीक है. So at this point if you calculate gradient you'll get normal. That's how you define the velocity potential function and the velocities. Okay. So now अगर किसी भी वेक्टर का यूनिट वेक्टर चाहिए तो इसके मैग्नीट्यूड से डिवाइड कर सकते हैं बस. ठीक है. सो देयरफॉर ग्रेडियंट ऑफ फाई इज इक्वल टू, चलिए इस फंक्शन का ग्रेडियंट कैलकुलेट कीजिए. सबको पता है कि ग्रेडियंट कैसे आएगा, डो बाय डो एक्स ऑफ दैट फंक्शन. सो डो बाय डो फाई बाय डो एक्स मैं थोड़ा सा लिखता हूँ कार्टेशियन में. डो फाई बाय डो वाई जे कैप प्लस डो फाई बाय डो जेड के कैप. ओके. अगर पोलर में चाहिए तो ग्रेडियंट का डेफिनेशन ये होगा. इफ सम ऑफ यू वांट टू रिमेंबर दिस यू कैन रिमेंबर, क्योंकि फ्लूइड मैकेनिक्स में भी काफी इंपॉर्टेंस है इसका. इजेड कैप. ठीक है. सो दैट्स इन पोलर बट लेकिन ये है कार्टेशियन में. फाइन. सो एनीवे ग्रेडियंट ऑफ फाई इज इक्वल टू डो फाई बाय डो एक्स. सो एक्स से डिफरेंशिएट किया तो 2xy प्लस 2z आई कैप प्लस x स्क्वेयर j कैप प्लस if you differentiate with z 2x k cap. Now we will substitute this point 2 -2, 3. So अगर substitute किया तो 2 2 are 4, 4 into -2 -8 plus 6 -2 I cap plus x square. So 4j plus 2x which is 4k of course. Okay. So this is gradient. So therefore gradient of phi is equal to -2i plus 4j plus 4k actually. So therefore magnitude of gradient of phi ये कितना होगा? 4 plus 16 plus 16 which is 6. Correct? 32 plus 4 which is 36. So this is 6 actually. Can't we take dot product as directly 0 sir? No. We should not. Okay. Fine. You should not see, but even to calculate the dot product you should know what is the tangent at that point. Okay. So again you should calculate d phi. So not needed. Okay. So this implies n cap gradient of phi by mod gradient of phi at that point. So -2 by 6 -1/3 I 2/3 j 2/3 k. ओके, सो ऐसे क्वेश्चंस काफी नॉर्मल सिविल मैकेनिकल में भी आते हैं, लेकिन यहाँ भी आने का काफी पॉसिबिलिटी है, पहले आए थे। सो -1/3 i प्लस 2/3 j प्लस 2/3 k, ऑप्शन ये सही है। ओके, इट्स ऑप्शन ये, स्ट्राइट फॉरवर्ड क्वेश्चन, राइट। अरे वाह, काफी लोग ने अच्छा कहे थे। अनंत, वाजत, सोया, मैकेनिकल रॉकस्टर्स, शर्मा, सोया, अंडरवर्ल्ड, डॉन, वहाँ पे विभू 2.0। चलो, लेट्स मूव टू द अदर क्वेश्चन। द वैल्यू ऑफ double integral r x plus 2y dA, where d is the region bounded by the parabolas y is equal to 2x square and y is equal to 1 plus x square, is dash. Come on, let's solve this. I is equal to integral over the region r x plus 2y dA. Okay, लेकिन d क्या है? I think this is r. Okay, r is the region, where r is the region bounded by the parabolas y is equal to 2x square and y equal to 1 plus x square. So ठीक है, पहले ये ग्राफ्स बनाएंगे हम, y equal to x square वाला and y equal to 1 plus x square. तो ठीक है, so y is equal to 2x square, पहले उस ग्राफ बनेंगे हम, 0 x y, so y is equal to 2x square, ये होगा ऐसे, correct? So maybe my drawing is very bad, but so this is y is equal to 2x square, ठीक है। y is equal to 1 plus x square, तो ये कैसे होगा? जब x 0 होगा इस फंक्शन का वैल्यू आएगा 1, ठीक है। so this is 1, so y is equal to 1 plus x square, ऐसा आएगा। so this is y is equal to 1 plus x square, ठीक है। now let us have the derivative, this region. So let us do with respect to y first, or y, so that you need not change the step. So this lower boundary, you can move this step from, let's say this, call this point A, and this is point B actually, and this AOB is the area which is bounded, correct? Then if this is A, if you move this step anywhere, bottom curve is always bounded by y equal to 2x square and top curve is always bounded by y equal to 1 plus x square, ठीक है। so यहाँ लिमिट्स कैलकुलेट कर सकते हैं, सिमेट्रिक ही होगा। so 1 plus x square is equal to 2x square, so x is equal to plus or minus 1, ठीक है। so ये होगा -1 कामा -1 कामा 0 of course, and ये होगा 1 कामा 0, okay, because points on x axis, ठीक है। so now let's see, if you integrate this, I is equal to x plus 2y, so let's take the first variable of integration, dy dx actually here, okay। so एक straight forward होगा, क्योंकि if you move the, if I have taken horizontal strip, okay, in this first quadrant when I move, यहाँ तक strip का left hand होगा y equal to 0, I mean x is equal to 0, but after this x is equal to square root of y by 2 ऐसा आएगा, ठीक है। so when you take x strip or horizontal strip, this question would increase in size, okay, the solution would become big, okay। so now if you see, so first y is equal to, so this bottom boundary is always guided by 2x square to 1 plus x square, and x is going from -1 to +1. Is this writing of limits clear to all of you? Everyone, type it in the chat box. Is this writing of limits clear to each and every one of you? Because in all multiple integrals, writing limits is the main crux part of the question, okay? Yes or no? Yeah, ठीक है। so let's solve this then. I is equal to integral x is equal to -1 to x is equal to 1. so integrate this. When you're integrating with respect to y, x is constant, so xy plus 2 into y square by 2, so this is y square within the limits 2x square to 1 plus x square dx, okay। so let's substitute. X is equal to +1, then x into, okay, so x into, then 1 plus x square minus 2x square. So 1 minus x square plus y square. Okay, so y square is this minus this. So y square 1 plus x square whole square minus 2x square. So if you add this 1 plus 3x square into 1 minus x square dx. This is what you would get actually, right? Laplace transform x syllabus lo unda ledu. Okay, but they don't ask you regarding the properties of Laplace transform, but they can ask you some simple integrals, like for example integral 0 to infinity e power minus x into sine 2x dx. So they can ask you these kind of questions, okay, where you can solve with the help of normal complex numbers and all. Okay, but in fact this has a direct formula in Laplace, but generally they can ask you. Okay, so let's see this value I is equal to integral x and x cube. So this integration would be definitely 0. This do not contribute. Minus 1 to 1 1 plus 3x square minus x square. So 2x square minus 3x power 4 dx. So if you simplify this, so everything is even function. So 2 times of x 0 to 1 x plus 2/3 x cube minus 3 by 5 x power 5. So within the limits 0 to 1. So if you solve this, 1 plus 2/3 minus 3 by 5. So if you multiply with 15, so 15 plus 6 minus 9 by 15. So this gives you, so 15 plus 6 is 21. 21 minus 9. 21 minus 9 is, how much is 21 minus 9? 12. So 24 by 15. 3 table 8 times, 3 table 5 times. So 8 by 5 is what I am getting. What are you getting? Two-dimensional Laplace equations unnai ga sir. Laplace transform is different from Laplace equation. Okay, fine. Do you understand? Laplace equation is this. Laplace transform is integration. Okay, so don't get confused between both. So I'm getting 8 by 5. Let's see whether we have an option. 8 by 5. We have 16 by 15, 32 by 15, 15 by 16, 15 by 32. So somewhere we have messed up. Where is it? xy plus y square. 1 plus x square to 2x square. Are you getting any of these options? Getting B? Okay, maybe then I have done somewhere. X plus 2y dy dx. So y equal to 2x square, y equal to 1 plus x square, plus 1 and minus 1. Yeah, correct. So y is going from 2x square to 1 plus x square. Yeah, that's also fine. 1 plus x square. X is going from minus 1 to 1. Okay. xy plus y square, 2x square to 1 plus x square. So x into 1 plus x square minus 2x square. So 1 minus x square. That's okay. Plus, so y square, 1 plus x square whole square minus 2x square. So a plus b into a minus b. 1 plus 3x square into 1 minus x square dx. Correct. X is changing from minus 1 to 1. So this is odd function x minus x cube. So that would be 0. 0 minus 1 to 1. 1 plus 2x square minus 3x power 4 dx. Okay. So 2 times of 0 to 1 x plus 2/3 x cube minus 3 by 5 x power 5. Okay. 0 to 1. 1 plus 2/3 minus 3 by 5. Okay. So still somewhere, can you do any catch here? It is 32. 15 plus 6 is 21. So let's see 15 table. So if you multiply with 15, here there is catch. Yeah, this last part is wrong. The simplification part is mistake. So let's see. This is 15. So if you take LCM, you have 15 plus 10 minus 9. Okay. So 10 minus 9 by 15 by 15. 35 minus 9. So 35 minus 9 is how much? Sorry, 25. 25 minus 9 is 16. So 32. 32 by 15. Yeah, that's all. Okay. Yeah, 2 5s are 10. Good. Correct. 2 5s are 10. I agree. Okay. 32 by 15 is the answer. Okay. Now do you understand why I miss 1 generally? 2 5s are 6. I do such wonders. Okay. After doing all these calculations part of it, I mess up here. So this is how what can cost you to miss AR1. Okay. So you should not do this stuff. No, it's important man. I should slow down a bit. Correct ना? क्योंकि ज़्यादा टाइम ऐसे फास्ट कैलकुलेशन करने की वजह से ऐसा कुछ होता है. Fine. But all of you, I strictly want to tell you one thing, that is 2 5s are 10. Okay. Not 9 or 6 or whatever. Chalo. So 32 by 15 is the answer in this case. Okay. Chalo, let's move. Something is given. For the matrix, some matrix, if a cube minus 13a square plus ka minus 17i is equal to 0, where I is identity of size 3 by 3, then the value of k is dash. Enter in integer. So same question, if you see, last time it was asked as some k is equal to 1 by a inverse into something, right? So let us solve. Yeah, you'll miss 2 marks. Not only 2.67 you'll lose because it has options, so negative marks. Okay? So you should be a little cautious when you're doing this stuff. Okay? So let's see. Given a is equal to 1 1 2 0 3 2 1 3 9 actually here. So this implies characteristic equation is, so let's see, lambda cube minus 13 lambda square plus 27 minus 6. So 27 minus 6, 21. Correct no? 3 9 27 minus 6, 21. 9 minus 2, 7. Then 3 lambda minus determinant 1 into 27 minus 6, 21 minus 1 into minus 2 plus 2 into minus 3. So minus 6 plus 2. So minus 6 plus 2 minus 4 plus 21 is 17. Okay. So 17 is equal to 0. So this implies lambda cube minus 13 lambda square plus 31 lambda minus 17 is equal to 0. So because of Cayley-Hamilton, we can say a cube minus 13a square plus 31a minus 17 times I is equal to 0. That's all. Okay. So this k is 31. That's all. Yeah. It's minus 2. Where? Not 7. So it's minus 2. Where? 7. Where is 7 first of all? Here. This minor. 9 minus 2, 7. No, it's 7. Okay. See, many of the times to calculate the characteristic equation, people do this determinant. Okay. Det of 1 minus lambda, 1, 2, 0, 3 minus lambda. Then again solving, multiplying cubic terms, arranging, it takes so much of time. Okay. And calculation mistakes also can happen. So the best way to write characteristic equation is straight within one step you'll get the answer. Okay. But you have to work the numbers a bit carefully. That's all. Fine. It's okay to all. Did you all find this writing characteristic equation in this way is much simple? Actually, within one step you get the equation. But you should do this additions and subtractions little carefully. That's all. How many of you have seen this for the first time in this batch or in this YouTube lectures? Like I have solved some questions in PYQs. How many of you have seen this writing characteristic equation for the first time? All of you know it before, or some of you learned it for the first time in this classes? Anyone? No? You all know it, right? I know you guys are legends. It's okay. So, but anyway, do this additions and multiplications little carefully so that you will get the things properly. Okay? Fine. Chalo. Let's move forward. Answer is 31. Okay. There's something given, MSQ. System of equations. Again, one very common thing. Choose the correct statement or statements regarding the below system. Kx plus y plus z is equal to 1. X plus ky plus z is equal to 1. X plus y plus kz is equal to 1. System has unique solution. System has unique solution for different values of k. System has multiple solutions for k equal to 1. This statement is definitely correct, I would say. Okay, because if k is equal to 1, then what happens? All these three equations tell you the same thing. Okay, so if you have only one equation with three unknowns, then infinitely you have many solutions. Okay, so this statement is definitely correct. I know this. So now let's see out of the remaining three which is the correct statement. Okay, so let's see. Let's form the augmented matrix. Solution: given system has the following form. Has the following form: k11, 1k1, 1k, 𝐂𝐳𝐬𝐬, 1. Okay, so what would be the augmented matrix in this case? Augmented matrix is A augmented B. If you call the system AX is equal to B. Okay, so this system has this form: k11, 1k1, 1k, 1. Fine. So this is what you get. So then let's get something. So when can the system has a unique solution, for example? Okay, so it's given k equal to 3, k equal to -1, k equal to 1. So definitely at k equal to 1, this has infinitely many solutions. So this is wrong. So -1 and 3, out of these two, there should be one way. So let's figure it out. What is the way? So let's apply the transformations. R2 changes to R2 minus k, k R2 minus R1, and R3 changes to k R3 minus R1. Okay, so if you do these transformations, k11, 1k1, 1, then k times of 1 minus k, 0, these two are zeros, k times of this minus 1, so k square minus 1. Okay, then k minus 1, so you have k minus 1, k minus 1. So k minus R1, so k times of this minus 1, so you have k minus 1 again here. Similarly here, k minus of 1, no, this is k square minus 1 again, so k square minus 1, and this gives you again k minus 1 actually here. Okay, now if you try to make this element 0, for example, then what you should do, R3 changes to k plus 1 into R3 minus R2. So if you perform this transformation, then you would get, maybe I'll take the next slide. So this system implies, so the first remains as it is, k1, 1, 1, then these two are zeros, so you have k square minus 1, k minus 1, k minus 1 actually here. Okay, and here if you see, if you multiply it with k plus 1, k plus 1 into this minus k square minus 1, this gives you 0. Then k plus 1 into this minus k minus 1. So let's do this, k plus 1 into k square minus 1 minus k minus 1 actually here. Okay, and this also becomes k plus 1 into k minus 1, which is k square minus 1 minus k minus 1 actually here. Okay, now if this system has to have unique solution, then this term should not be 0 actually. Okay, yes, if this is non-zero, then definitely the system have a unique solution. So which means k should not be equal to 1, k should not be equal to -1. In these two cases, it has unique solution. Okay, so then the only option is this, k equal to 3. Okay, clear? So if you have either k equal to 3, then definitely it has a unique solution, or if k equal to 1, then it has infinitely many solutions. That's all. Basically, if you see, for this system to have unique solution, the determinant should not be 0. That's all. Okay, that's what, after doing the final step, you'll come to know that if you take determinant of k, for example, so this should not be 0 actually. Okay, so that's the simple condition. when you have a non-homogeneous system actually. Okay, so if you have a non-homogeneous system and this happens, then definitely system has unique solution. You can check. This is exactly same as this equation if you check. Okay, that's a short technique, but since I just want to tell you the classic procedure first, how to do the things, I thought of doing this. Okay, chalo, it's fine to all of you. If k is equal to 1 or k equal to -1, then the system will have sorry, if k is equal to k should not be equal to 1 or k should not be equal to -1, then the system should have unique solutions. Okay, which everything of this analysis tells you. Okay, so A and D are the correct answers. So let's see the correct solution of the differential equation 1 by x square d square by dx square plus 1 by x cube dy by dx plus 1 by x power 4y is equal to 1. Solve this question. I'll give you 2 minutes. Okay, 1 minute. I'll have water meanwhile. So solve this question. Solve this differential equation. MCQ. Okay, so let me solve this. Solution. Given DE is 1 by x square d square y by dx square plus 1 by x cube dy by dx plus 1 by x power 4 y is equal to 1. Can any one of you suggest me something so that this equation looks in one of the standard forms? So can any one of you suggest me something? Something if I do, this equation comes in very standard form, which is known to all of us. And that is one of the most frequently repeating questions in XE. Fantastic. Multiply by x power 4, correct? So if you multiply with x power 4, so this implies x square d square y by dx square plus x dy by dx plus y is equal to x power 4. So this would be the equation. And what is this equation? Euler-Cauchy equation, correct? So you have the Euler-Cauchy equation. Okay, so if that's Euler-Cauchy equation, let us solve this. Let x is equal to e power z. So this implies d into d minus 1 plus d plus 1 operating on y is equal to x power 4. So x power 4 would be e power 4z. That's all. Okay, so e power 4 z. So obviously if you simplify this, d square minus d plus d cancels, plus 1 operating on y is equal to e power 4z. So this gives you y is equal to c1 e power z plus c2 e power minus z plus, so 1 by d square plus 1, 17. So e power 4z by 17, so x power 4 by 17. That's all. This is the solution. Correct? Shall we check if this is there somewhere? Yay. It's not there. Good. Because the roots are plus or minus I. So c1 cos z, c2 sin z. So cos ln x plus sin ln x. This is the solution actually, right? Because yeah, it's complex, no? That's why. So you can see, anyway, this is the final answer. But if you do this, auxiliary equation becomes m square plus 1 is equal to 0. So m is equal to plus or minus I. So the complementary function is c1 cos z plus c2 sin z. Okay, but this z is nothing but ln x. Okay, so z is equal to ln x. So the complementary function is c1 cos ln x plus c2 sin ln x. Okay, so that's how you have the complementary function. Now if you want the particular integral, so how do you do this? Yp is equal to 1 by d square plus 1 operating on e power 4z, so which is e power 4z upon 4 square plus 1, so this is e power 4z by 17, so this is x power 4 upon 17. That's all. So you add this plus this, you get the final solution. Okay, Euler-Cauchy equations very popular in XE, so I thought of putting one question, but not to directly give you the thing. Okay, I thought of dividing it with x power 4 so that instead of having x square in the numerator, you'll have x square in the denominator now. Okay, so in exam they can give you some questions which can trick you like this, a small bit of trick, so that by just doing one step you'll know the standard form. Okay, did you all like this question? How many of you have liked this question? Tell me. So that it's a very standard form but not indirect. Okay, so I have d square will be equal to minus a square, na sir. That happens only when there is sine or cos. Okay, so d square becomes minus a square only if you have the sine function or the cosine function here. Okay, not always. You should be careful. Okay, fine. If you have exponential functions, directly you can substitute. And if you have constants, so like for example, instead of this e power 4z, okay, sorry, instead of this e power 4z, if you have a constant, okay, so constant can always be written as into e power 0x or 0z, whatever, then you can again treat this in this form with a 0 here, then it would be much easy. Okay, so let's move to the next question. So this is the correct answer. No, sorry, cos ln sin ln, yeah, so this is the correct answer. Okay, so solve this question. If y of x satisfies dy by dx plus 2y is equal to 2 plus e power minus x with y of 0 is some positive initial condition, limit x tends to infinity, y of x is dash. So let's solve this. This is equal to 0, sorry, yeah, initially starting from 0. Okay, so y of 0 is equal to 0, then limit x tends to infinity, y of x is equal to dash. So solve this question. It's a very simple question. Meanwhile, I'll try to answer this question. You solve this. I think answer is 1. Maybe there could be chance. Anyway, we'll solve this question. Okay, step by step solve karenge. So solution, given d is dy by dx plus 2y is equal to 2 plus e power minus x, correct? This is in one standard form. Can anyone tell me what is this form? Can some of you tell me what is this initial form actually? This equation is in one standard form. What is the standard form? Linear, yeah, non-linear differential equations you don't have in the syllabus. ठीक है, हमेशा हम linear equations को ही solve करते हैं. Py plus q, it's called Leibniz linear equation. Okay, Leibniz linear differential equation. ठीक है, so what about the integrating factor? Integrating factor e power integral 2 dx, so which is e square. Okay, so this implies solution y into e square is equal to integral 2 plus e power minus x into e square dx plus constant. Okay, so if you solve this, then then what do you get actually? Let's see. So y e square is equal to integration of 2e square, so 2e square into x plus e square into integration of e power minus x, so e power minus x by minus 1, so this becomes minus. Okay, so this plus some constant. Okay, but anyway e square is just a constant term, so you can eliminate the constant all over. So this e square will be some another constant. Okay, because some constant divided by e square is some other constant, that's all. E power 2x. No, see, if you multiply e power minus x into e power 2, this is e power 2 minus x. Okay, not e power 2x. Clear? Fine. This is 2 minus x, not e power 2x. Okay, so let's see, we have y is equal to 2x minus e power minus x plus some constant. Okay, so it's given y of 0 is equal to 0. So this gives you 0, 2 times of 0 minus 1 plus c dash. So c dash is equal to 1. Okay, so c dash is equal to 1. It should be 2x. Sorry, if is e power 2x, is it? Yeah, sorry. This is 2x. Then this story changes. So you should be careful, okay? Sorry. 2. This is not this because I missed 2x. Okay, so let's see. This is e power 2x. Integration of 2 dx is 2x. Yeah, correct. So integration of e power 2 dx is 2x. So solution is y into e power 2x integral 2 plus e power minus x into e power 2x dx plus some constant. Okay, so y e power 2x is equal to integration of 2 into e power 2x. So 2 e power 2x by 2, correct? Because 2 is just a constant. Integration of e power 2x is e power 2x by 2 plus e power minus x into e power 2x. So that gives you plus e power x. So e power x by, that's all. Integration of e power x is e power x plus some constant. So if you delete this e power 2x all over, okay, so this is the value. So therefore y is equal to 1 plus e power minus x plus some constant into e power minus 2x. Okay, so they have given you some boundary condition, but as x tends to infinity, y is equal to limit x tends to infinity 1 plus e power minus x plus some constant into e power minus 2x. So definitely, you know, this term and this term will go to 0, so you'll be left with 1. Okay, so that's all. So therefore limit x tends to infinity, y is equal to 1. Got it? But to solve this question, you need not do all this business. It's a simple thing. Look, dy by dx is equal to plus 2y, whatever. So plus 2y is equal to 2 plus e power minus x. This is the differential equation, correct? Now dy by dx tells you the change in y with x, correct? अगर आपने x को थोड़ा सा चेंज किया तो y कितना बदलेगा? That's what dy by dx tells you. Now if x is tending to infinity, means at a long time, if things are becoming steady, what should be this value? Tell me. As x tends to infinity, this dy by dx value tends to, let's in place of x you have t, time, for example. Okay, so dy by dt is equal to 2y is equal to dy by dt plus 2y is equal to 2 plus e power minus t. That's the equation. So as things tend to infinity, if things reach steady state physically, then what should be dy by dx? 0, correct? So as x tends to infinity, things reach to steady state, this e power minus infinity goes to 0. So at x tends to infinity, this equation reduces to this form. That's how I told y equal to 1 without even solving the question. Understood? Got it? So how to check function is homogeneous or not? In case of multiple variable, in case of single variable functions, okay, if you have multiple variable, if this is happening, functions are homogeneous of nth degree. If not, they are not homogeneous. Okay. Okay. Yes. K is constant here. Okay. That's how. So if you model this system as some physical system, as things tends to infinity, this unsteadiness in the system will go, and this term is 0. So this complete equation reduces to this simple equation. So that's how we'll get y equal to 1. Okay, fine. So it's almost 1 hour 20 minutes, almost 80 minutes. We had some fatapat solving of the questions. So I just want to spend some 4-5 minutes. If you need anything about 𝐿𝐸 or anything, you can ask me now. Anything that I can help you out with 𝐿𝐸? Nothing? Everything is fine? So we have started with fluid mechanics. I think I have started the PYQ session in fluid mechanics the first day after mechanical exam. So then we have gone to thermodynamics, solid mechanics, maths, of course, a lot of stuff. But unfortunately, yesterday's session got hampered a bit. After 𝐿𝐸, how to start PSU exam preparation. ठीक है, पहले 𝐿𝐸 एग्जाम होने दो, उसके बाद मैं PSU कैसे क्लियर करना पड़ेगा ये सब के बारे में वीडियोस करता हूँ. ठीक है, पर लेकिन 𝐿𝐸 अब तक 𝐿𝐸 के लिए सोचो. ठीक है. So how to check homogeneity in linear algebra? In previous question in linear algebra, you mentioned some non-homogeneity in that question that had unknown constant k. Basically, if see what does homogeneous tells you physically is every term should have equal degree. Okay, like for example, you see this has x power 1, so there is a variable and the variable degree is 1. Here also 1, here also 1. But here you see, if you want to write it as variable, either you write x power 0 or y power 0 or z power 0. So this is the term of 0th degree, but whereas all these three terms of first degree. So if you want to call a equation homogeneous, then you should you should have every term of same degree in that equation. Okay, like in this first equation, this first all the three terms on the left hand side, they have a degree of 1, but on the term on the right hand side you have 0th degree, so that's not homogeneous. Okay, but if there is 0 on the right hand side, then it is homogeneous because you can write 0 into x power 1 and you can match the degree. Okay, fine. Correlation and regression of good weightage, not much generally, but in 𝐿𝐸 they can ask you about the regression sometimes. Okay, the linear regression and all, but generally it's very rare because nobody expects you to remember the questions. If really they ask you, you should use this functions and do the things. Okay, I only follow these YT sessions. Is this okay? Yeah, to the best possible you have done. How much time should be given to aptitude? Almost some 25 to 30 minutes. Yeah, okay, because 15 marks is really important. How to approach after looking at partial derivatives, like basic idea in case of wave equation and heat equations. Like Parthasadi, if you see, we have solved PYQs no regarding heat equation and wave equation also. One question we have solved, so that's how you'll figure it out. Okay, what are the process I have dealt? Like you remember the standard solutions, like in case of wave equation you have the D'Alembert solution, in case of heat equations we have the general solution form. So once you have the general solution, you understand the the boundary conditions first, and then substitute the initial condition and compare with the sequence. You'll know the constants. Okay, please explain the de Moivre theorem. Yeah, I'll explain you. In numerical methods, linear algebra and probability, what are the important topics to cover? Numerical methods, basically this Newton-Raphson method. Okay, and Simpson's quadrature rules, basically trapezoidal, Simpson's 1/3 and all. Linear algebra, you can do eigenvalues and eigenvectors, diagonalization. Okay, and the properties of determinants sometimes. Probability, normal distribution, and some Bayes theorem questions basically. Okay, and I have told one question in PYQs, like infinitely the people throw dice, all these basic questions. Okay, de Moivre's theorem actually tells you this. For n belongs to z plus cis theta whole power n is equal to cis n theta. Okay, for n belongs to p by q, cis theta whole power n is equal to cis 2n pi plus theta times p by q, where n is equal to 0, 1, 2, 3 and so on, q minus 1. This is what you have the demo is there basically. Okay, that's what you have the demo is there. Correction predictor method kya hua? But don't worry, it's not there for gate. But normally character predictor methods, what you have in the character predictor methods is, first you don't know a solution, so you'll predict the solution using some technique, okay? But whatever that you have predicted need not be the actual solution, so you'll start correcting it. This prediction correction, you'll keep doing it in loops again and again, okay? That's all. So I focus majorly on design and thermal. It's okay, no issues, but yeah, you can decide, okay? In extra topics of FM, like last time I have told you, like 4 or 5 days back, we have made a playlist, okay, of special topics. So just have a look through the playlist. It would be advantageous. Okay, fine. एक बार बाइसेक्शन मेथड एक्सप्लेन कर दीजिए. ठीक है, मैं करता हूँ, कोई दिक्कत नहीं, लेकिन अभी सीखने की जरूरत क्या है. ठीक है, ओके, आई एक्सप्लेन यू. इंपॉर्टेंट टॉपिक्स ऑफ प्रोबेबिलिटी एंड स्टैट्स, बेस थ्योरम क्वेश्चंस एंड distribution, normal distribution questions. Okay, normal distribution, Bayes theorem questions, and some general questions on random variables. That's all. Okay. Euler correction and trapezoidal prediction methods, how can we use? Okay, so basically we don't predict using trapezoidal. In fact, okay, many times that's special techniques in solving differential equations. Right now it's not in the syllabus, okay, but maybe if you are interested after gate exam, I'll take some session. Okay, that's a very simple technique. Normally if you have even PDEs, we go for those techniques of Euler correction and all, but right now let's not discuss it, okay, because it's off the track. In bisection, what you do is, just I'll give you some glimpse because किसी ने मांगा था, sorry, पूछा था, whatever. So bisection method, so this tells you, if you have the function like this, okay, so x, y, and let's say you have this function, which is some nonlinear function. So if you see the bracket tool, if you point out a function x is equal to a here, so you point x is equal to a, and this point x is equal to b, such that this f of a and f of b, say something like this, this is f of b. Now one thing that you know definitely 100% is, if the function is continuous, the function is not breaking anywhere, okay, the function is continuous, smooth, and if you have 2 points of x equal to a and x equal to b, such that this f of a and f of b has opposite signs, okay, like maybe f of a is positive and f of b is negative, or vice versa, f of a is negative and f of b is positive, whatever. If they have opposite signs, means if they are satisfying a condition, f of a into f of b is less than 0, means one of them is positive, other is negative, then definitely there exists a root at some point. Yes, correct or wrong? Can I say this? If you have 2 values of a and b, and if these two have opposite signs of the functional value, then definitely there exists some root between a and b, okay, you know that there exists a root between a and b. So this tells you x belongs to a comma b, such that f of x is equal to 0. Good, you know this. Now what you do is, in bisection method, bisection, the name itself tells you, you'll break this interval into 2 parts. You generate an iterate value c is equal to, calculate c is equal to a plus b by 2, okay. Initially you know that the root is somewhere in between this, okay, but if you have c is equal to a plus b by 2, and if you calculate f of c, for example, okay, calculate f of c, calculate f of c, for example, okay. Now if f of a into f of c is positive, means if they have both signs, same signs, then x belongs to c comma b. X is the root. Okay. If f of a into f of c has opposite signs, then the root lies in between a comma c. Yes, will you all agree with these statements? Once you calculate c, if f of a and f of c has same signs, then definitely there is no chance that a root lies between a and c. Then a root should lie between c and b. Like for example, if this is c, okay, you have calculated somewhere, this is c actually. So this is f of c, the first iteration you have done. Okay. So if you have done this first iteration, and if you figured out f of a and f of c has opposite signs, then definitely root should lie between a and c, which means initially you know root lies in a and b, but now you are able to delete this interval. Okay. Now you 100% know that the root is not in this interval. Clear? In the next iteration, you will reduce the interval to 1/4, 1/8. So finally, after 5-6 iterations, you will have a very narrow range, like maybe something like 0.2734 to 0.2741. So let's say you got something like this, the interval. Okay. Then after one more iteration, you will see this interval and this, the limits of the interval will be very close. That's where you have the actual root. Did you understand the technique, how we do this? Yes. So you keep shrinking the interval and finally, eventually you'll stop at the root. That's what bisection. But generally, why we don't use bisection very frequently, the rate of convergence in bisection is linear, it's 1. Okay. But you have a quadratic convergence for Newton-Raphson method. So Newton-Raphson is faster. Like whatever the answer you get in 5 to 6 steps in bisection method, that you will get within 1-2 iterations in Newton-Raphson method in reality. Okay. That's why it's very powerful, and that's the reason why in GATE many of the questions you see will be Newton-Raphson questions. Okay, so that they expect you to do 1-2 iterations and get the answer. Okay, there are plenty of techniques, like even in optimization of multivariables and all, you'll have very faster convergences. Okay. Anyway, since you have asked, I have done this. Now again, the new interval is a to c. So again, you calculate midpoint of a and c, you'll get somewhere d. That's how you keep shrinking the interval. Okay. So let's solve this. Choose the correct statement or statements from below. For any square matrix A plus A transpose is always symmetric. For A and B are symmetric matrices, then AB minus BI is also symmetric. If AB are symmetric matrices, AB plus BI is also symmetric. Eigenvectors of a symmetric matrix are pairwise orthogonal. A real symmetric matrix, you can say, of a real symmetric matrix are pairwise orthogonal. Come on, tell me the correct statements. What are the correct statements in this? Just a minute, guys. Meanwhile, mark the correct statements in that. Okay, now it's fine. It's okay now? Sorry, yeah, there was slight issue, but it's okay now. Yeah. So, like you can see, this A plus A transpose is always symmetric. In fact, if you take any square matrix, okay, so see what I was doing is, if I want to show that this matrix whatever this matrix combination A plus A transpose is symmetric or not, I can do this. A plus A transpose I am taking it as C. Okay, so because A plus A transpose will also be another matrix. Okay, so if that matrix I can show C transpose is equal to C, then the matrix is symmetric. Otherwise it's not symmetric. Okay, so I have considered C transpose, which is this, since C is this combination, so this combination whole transpose. So since A plus B whole transpose is equal to A transpose plus B transpose, then this can be broken up into two parts, which is A transpose plus A transpose whole transpose. So if you transpose even number of times, you'll get the same matrix, and odd number of times you'll get the transpose. Since addition is commutative, you can swap these two. So it's same as C. So C transpose is same as C, which means C is symmetric matrix. Okay. So in fact, you'll see any square matrix, this can be written as half A plus A transpose plus half into A minus A transpose actually, and this is always symmetric, and this is always Q symmetric. Okay, this is one very important point. Any square matrix can be split up into, decomposed into two parts. One is symmetric, which is this, and this is always Q symmetric. Okay, so statement A is definitely correct always. Yes, is this okay to all of you? A very simple understanding, in fact. Okay, everyone, is this clear to all of you or not? I'll also tell you one more thing. Also, A transpose is always symmetric. A transpose is always symmetric. Okay, like for example, you can see, let C is equal to A transpose. So C transpose is equal to A transpose whole transpose. So this gives you A transpose whole transpose into A transpose. So A transpose, which is same as C actually. So C transpose is equal to C again in this case. Like if you generalize this, since AB whole transpose is B transpose into A transpose. Okay, so this is what you get. Interesting session. Okay, good. तब by 2 होगा तब n सिमेट्रिक होगा A प्लस A ट्रांसपोज by 2 डेफिनेटली, क्यों नहीं? मान लो कि एक सिमेट्रिक मैट्रिक्स लिया आपने, ठीक है, सो उस मैट्रिक्स को किसी भी स्केलर से मल्टीप्लाई कर लो, जो रिजल्ट आएगा वो भी सिमेट्रिक होगा, करेक्ट? लाइक फॉर एग्जांपल, इफ आई हैव 1 2 3 2 4 7 3 7 6 something like this. Okay, so now you multiply this matrix. This is symmetric matrix, like you can check it is symmetric. ठीक है, now you multiply with any scalar. Let's multiply with 2, for example, 2 4 6 4 8 14 6 14 12. Okay, so if you have this matrix, this is also symmetric, correct? So that's always symmetric. If you have a symmetric matrix, you multiply it with any number, the outcome is also symmetric again. Okay, but in skew symmetric matrix, A transpose is equal to minus A. Okay, so then A plus A transpose is 0, that's all. See, if A transpose is equal to minus A, then A transpose plus A is equal to 0, that's all. Okay, for this matrix to be skew symmetric, this summation should be definitely 0, but here this is non-zero. Okay, yes, so this should be non-zero. See, if this is 0, then there is no point. A should be null matrix. Okay, if this is 0, then 2A minus A is equal to minus A transpose is what you will get from this equation. Like if you make this term 0, for example, okay, 2A is equal to A minus A transpose. So this again gives you A equal to minus A transpose, which is skew symmetric. Okay, so all this is analogous to each. Fine. Clear? Any doubts to anyone? If you have any doubts, please ask me, or else please respond in the chat box. Clear? It's a very straightforward stuff. Nothing complicated also. Okay. very easy things. So yeah, let's go to the next statements. If A and B are symmetric matrices, then AB minus BA is also symmetric. False. Why? See, I'll tell you why. Why this should happen. Anyway, I'm erasing this, okay, just to clear one of your doubts. I have done this, but given second statement, okay, A and B are symmetric. So what does this tell you? A is equal to A transpose, B is equal to B transpose. This is known to you, correct? Yeah, some fun stuff, fun activity, okay. So let's see. Now we are worried about this combination AB plus BA or minus BA, whatever. So first start with minus BA. So this is what you have, okay. Now you want to figure out this matrix is like skew symmetric or symmetric, okay. So let's see. Let C is equal to this. Now if I want to show this matrix is symmetric, I should show C transpose should be C, or if this matrix has to be skew symmetric, then C transpose turns out to be minus C, okay. So let's apply transpose on both sides and let's see what happens, okay. So C transpose AB minus BA whole transpose, okay. So since this is a matrix and this is a separate matrix, I can write this as AB transpose minus BA transpose, correct. So you have the multiplication rule. So C transpose is equal to, so this is product of two matrices whole transpose. So B transpose A transpose minus A transpose B transpose, okay. Now clearly these are symmetric matrices. So this I can replace A transpose with A and B transpose with B. So C transpose is equal to BA minus AB. So if you take a minus sign common, AB minus BA. So AB minus BA is actually C. So this is minus C. So therefore C transpose is equal to minus C. So this tells you AB minus BA is skew symmetric. It is not symmetric. Got it? So did you all understand why second option is a wrong option? Because the matrix combination is not a symmetric matrix, it's a skew symmetric matrix. Okay. Sharma, Damjit, Vijay, Akash, Bharat, Rohan, Vibhu, other names, whoever. So is this clear to all of you? Yes. Okay. So that's why this fellow is a wrong choice. It's not symmetric. If it is AB plus BA, it is definitely symmetric always. Okay. Like you can see, instead of minus, if I have plus, okay, I'll have plus, plus. Now this addition is commutative. Okay. I can replace BA plus AB as AB plus BA. See, I cannot replace AB as BA. Got it? How BA plus AB is same as AB plus BA is because I can swap these terms, okay, but I cannot write AB as BA because you know matrix multiplication is not commutative. Okay, sometimes AB exists but BA don't even exist also. Okay, forget about the equality. Like for example, if I take A is equal to 4 by 2 and B is equal to 2 by 3, okay, in this case you'll have AB because these two are equal. Okay, but if you write BA 2 by 3 and B is 4 by 2, then matrix multiplication is not feasible. Okay, so matrix multiplication need not be commutative. Okay, it's associative but it's not commutative. Okay, associative in the sense if you have three matrices, you can first multiply these two and then multiply A, or you can first multiply these two and then post multiply C. In these two cases answer will be same, but not in this case. I mean in this case. Okay, it's not commutative. Clear? So that's why this is wrong. I mean this is the correct option. Okay, so C is correct. The eigenvalues of a real symmetric matrix are pairwise orthogonal. This is also true actually. Okay, because you see, like many of you might have seen this stress tensor. Okay, So when you calculate the stress, when you see the stress tensor, I'm just giving an example because to prove that it is a very long proof, in fact. Okay. So right now I'm not proving that, but I'm just showing you the idea. I could have done with an example by taking symmetric matrix, calculating eigenvectors, showing dot product, all this stuff. But anyway, that's not that case. So in this question, matrix unique solutions is mixed. Operations are valid. Yeah, why not? You cannot do the column operations, Aditya. Okay. Row operations you can do as many as you want, but column you cannot do. Got it? Because if you do column operations, coefficients change. Then the system will change, definitely. Okay. But playing with those is just playing with the equations, putting them or arranging them. That's all. So that doesn't change the system. You can do. Okay. Now I was speaking something. Stress tensor. Okay. So all of you might have seen this matrix, no? At least. Maybe you might have seen this as tau by x. Okay. If you calculate the principal planes, like you know the principal stresses, sigma 1, sigma 2, those are nothing but the eigenvalues. And if you calculate the principal planes, okay, then those are the eigenvectors of this matrix. So what is the angle between two principal planes? At a point, if you have the state of stress, what is the angle between two principal planes? What is the angle between two principal planes? Some of you who are writing solid mechanics. 90. Okay. Because when you apply the momentum balance, this tau by x and tau xy becomes equal. Okay. So this matrix is a symmetric matrix. In fact, if you see sigma 1, sigma 2, whatever you calculate using these formulas, okay, sigma xx plus sigma yy by 2 plus or minus root of sigma xx minus sigma yy by 2 whole square plus tau xy square, whatever the values you calculate using these formulas, they are nothing but the eigenvalues of this matrix. Okay. The eigenvalues of a real symmetric matrix are always real. Okay. You might have seen you'll never ever get complex this complex numbers for the principal stresses. You always get real numbers because it's a symmetric matrix. So eigenvalues of a real symmetric matrix is always real. Okay. And you might have also seen something, sigma 1 plus sigma 2 is equal to sigma xx plus sigma yy. You might have seen this. Okay. You might have derived this because sum of eigenvalues should be equal to trace of the matrix. Okay. And it's symmetric matrix, so the eigenvectors are always orthogonal. That's where the principal planes. Principal plane directions are nothing but the eigenvectors of this matrix, and the principal planes are always at 90 degrees inclined to each other. Okay, or they are orthogonal basically. So all these points are basically from this linear algebra, from this symmetric matrix. Okay, it's fine. Can you connect all these dots now? Telegram doubt, 1 minute. Let me check my Telegram so that Akash has put some doubt there, maybe. I did not get, man. Just let me check once again. Abhyas. Akash Sidhu. Where it is? You please tag it again, okay, so that I can see the question, because there was some good number of messages. So anyway, like if you have a question, just put it in this Vanessa PW channel so that I can look at it. As of now, you can see only the message which I posted has it. Okay, fine. So this is also correct. So A, C, D are the correct options in this case. Chalo, let's go to the next question. Solve this MCQ, multiple choice question. The value of limit extends to infinity sin x by x plus integral 0 to 4 root x by root x plus 4 minus square root of 4 minus x dx is dash. Explain about series. It is always becoming wrong if possible with an example. Definitely, Aditya, we have some questions we'll solve. Okay, as we move forward. Consider the following system of equations: x plus y plus z is equal to 1, x plus 2y plus 4z is equal to n, x plus 4z 4y plus 10z is equal to n square. For what values of n does the system has infinitely many solutions, and what is the corresponding general solution for x, y, and z actually here? Okay, we can solve this, no issue. N equal to 1 with the solution of this, n equal to 2 with the solution of this actually. So first of all, if this system, okay, let's solve this question, then I'll get back to this. Okay, yeah. So what is this answer? Option B, Rohan, correct. B is the correct choice. Okay, so let's see how we can do this. Limit extends to infinity, sin x by x. What is this answer? Any one of you? First, let's go term by term. So what is that value? 0, straightforward, right? Because whatever the value you put in place of x, a value in -1 to 1, okay, it's a finite value divided by infinity. It's a long, very big number. So this is equal to 0. Okay, many people feel it 1, but as soon as you put sin x by x, but always the sin x by x value is not equal to 1. Okay, when x is tending to 0, this sin x by x falls to 0 because sin x by x has terms which are less dominating than this. Okay, then integral 0 to 4 square root of x root x plus root 4 minus x dx is 2. That's all. Okay, so how this can be 2, I'll just explain you in a brief thing. Since integral a to b any function by the same function plus f of a plus b minus x dx is b minus a by 2. If a equal to 0, then answer is b by 2. That's all. Okay, so half of 2 is just half of 4, which is 2 actually. How many of you don't know this part? Please tell me honestly. How many of you don't know this? It's okay, be honest. If you don't know, I'll explain you how does this result turn up. Like you see, if you compare this, f of x is root x in this case. That's all. So root x by root x plus square root of 0 plus 4 minus x. So 4 minus x dx. So if you compare these two. So Vinay and Rajit, Indu, learn in +2, I think. Don't know. Okay, fine. So let's see. I'll just do some 1-2 steps. You'll understand. Equation 1. Okay. So now since integral a to b f of x dx, this can be written as integral a to b f of a plus b minus x dx. You all know this, right? This is basically the shifting property, correct? You shift the x by a plus b minus x actually. So if you observe this, the same equation, this implies I is equal to integral a to b f of wherever there is x, you can put a plus b minus x. F of a plus b minus, instead of x, you can replace with a plus b minus x dx. Okay, so basically whenever you have this integration, wherever there is x, you can replace with a plus b minus x actually. Okay, so then this I is equal to integral a to b f of a plus b minus x by f of a plus b minus x plus f of minus plus x dx. Equation 2. Okay, so therefore 1 plus 2 gives you I plus I, 2I integral. Now you see these two integrations, denominator is same, limits of integration is same. So can I write a to b? If you add these two, I can write in the common denominator f of x plus f of a plus b minus x. This integration gives you f of x. This gives you f of a plus b minus x dx. Okay, 1. So this integration is b minus a. That's all. Okay, so 2i is b minus a, so I is b minus a by 2. Okay, that's all. Fine. Integration of a to b 1 dx is nothing but b minus a. Okay, but b minus a is 2 times of I. Okay, so I should be only half of b minus a. So b minus a by 2. So that's how this is 2. So 0 plus 2 is 2. That's all. Now let's go to that question which one of our friends has asked in the Telegram channel, Akash. So consider the following system of equations. Okay, for what values of n does the system have infinite solutions, and what is the corresponding general solution for x, y, and z? That's the question. Okay, so for what values of n the system has infinitely many solutions? Look, if you write this system as correct, so this is the value. Test series का question. अच्छा पता नहीं मुझे किस test series का XC का, because I myself have did this test series but I don't remember I have given this question. Anyway, let's see. Fine. Okay, so AX is equal to B. If this system has to have infinitely many solutions, for infinitely many solutions, rank of A should be same as A augmented B, which is less than 3 actually. Yes. Now, if this has to be less than 3, then determinant of A should be 0 and all 3 by 3 minus of A augmented B should also be 0. Correct? Yes or no? All 3 by 3 minus of A augmented B should also be 0. So you take any 3 by 3 minor, 1, 1, 1, 1, 2, 4. So 1 n n square. This is also 1 minor, it should also be 0. So if you solve this, you'll get quadratic equation for n. Okay, so let's see. 1 times of 2 n square minus 4n minus 1 into n square minus n plus 1 into 2 is equal to 0. So 2n square minus n square minus 4n plus n okay, n equal to 1 comma 2. Clear? Did you all understand how did I make this determinant equal to 0? In fact, out of these 4 columns, like if you form the augmented matrix, this matrix plus this column will also come here. So any 3 by 3 minor you take such that it involves this column definitely, so that you'll have n. Okay, then these are the roots. Now if n is equal to 1 and n is equal to 2, then this system has infinitely many solutions. Correct? So what are those infinitely many solutions? Let's see. For n equal to 1, for n is equal to 1. So if you put n equal to 1, this system becomes x plus y plus z is equal to 1, x plus 2y plus 4z is equal to 1, x plus 4y plus 10z is equal to 1 actually here. Okay, so this is the system. So let's see the options. X is equal to 1 plus 2z, y equal to minus 3z, z is equal to z. Of course, z is equal to z in all the cases. What is the connection between y actually? So let's see. If you call this 1, 2, 3, so you do 2 minus 1. So 2 minus 1 if you do, 2y minus y is y plus 4z minus z is 3z is equal to 0. So y equal to minus 3z in this case. So y equal to minus 3z, which is there in option A actually, but not in option B. How did you eliminate third column? Look. Correct? This is the augmented matrix. Now if this augmented matrix has to have a rank of less than 3, okay, till now. Now if you have this is anyhow 0, you can calculate it's 0 clearly. Then you take any 3 by 3 minor such that it involves this n, because I want to know what are the values of n. Okay, so you keep this column, and out of these three you take any two columns and form a determinant. Definitely that determinant should be 0. Correct? Did you understand, Akash? I want the values of n, so all 3 by 3 minors of this augmented matrix should be 0. So I am retaining this column because I want the values of n, and from these three columns I am taking any two columns and I am forming a 3 by 3 det and equating to 0. Got it? Clear? Got it? So that's how n got to be 1 or 2. Okay, that's what I got. Fine. So when you take n is equal to 1, then you got y equal to minus 3z, which is in the first option. Okay, you did the O-echelon form. Even then you should get the same answer. You will get the same equation. Even if you did the O-echelon form, you would have got the same equation finally. Okay, then maybe you would have got slightly different, like n square minus 1 is equal to n plus 3 n plus 2, something like that you might have got. But if you simplify, this equation would remain as it is. You can check if you want, because whatever the way you do it, you should get the same things. Okay, let me have some water meanwhile. So if you have any questions, you can ask till this point. Okay, so now if you take n is equal to 2, then what happens? This y plus 3z is equal to 2 minus 1 is 1. So y is equal to 1 minus 3z is what you will get, which is in the option D, of course. Okay, so A and D should be the correct answers in this case. Okay, clear? So A and D would be the correct answers in this case. What are the question you have asked? Because if you put n equal to 1, this is what you get. If you put n equal to, this becomes 2. So here you'll have 1. So y equal to 1 minus 3z is what you would get. Okay, Akash, Sidhu. Chalo, let's go to the next question. So let's see the value of the integral I is equal to 2.87 to 3.87, 4.52x, 6x plus 0.927 dx evaluated using trapezoidal rule is t, and the value obtained by analytical integration, so normal integration, is I. The value of mod t minus I is dash. Take step size h is equal to 0.2 while evaluating t. Obviously, for calculating trapezoidal rule, you should know the step size. So they're asking you to take the step size of 0.2. So just do and write the answer. What's the answer in this case? So I could see the group now. Which group? This Telegram. Oh, that's what, na? So n square minus 3n plus 2 should also be 0. Yes. Now definitely that's what the correct answer, right? Yeah. This should be 0, obviously. Why? This is a linear function. And in trapezoidal rule, order of fitting polynomial is 1. So either if you have a constant function or a linear function, the value calculated using trapezoidal rule should be same as the analytical value. Correct? So there should not be any difference. So answer should be 0. So let's see. I'll just write a word explanation. For integral a to b f of x dx, if f of x is a polynomial of degree less than or equal to 1, why? Since order of fitting polynomial is 1 actually. Okay, if you take n as 1, both ranks would be same answer. Obviously. But both ranks would be same, but less than 3, correct? It would be 2. You can check. If it is both ranks are equal and if it's equal to 3, only then unique solution. If both ranks are equal but less than 3, then infinitely many solutions, correct? And if you put n equal to 1, you'll get rank as 2, of course. Okay? Because the last row fully is 0. And rank is equal to number of non-zero rows in echelon form, so you have only 2. It should be same, both ranks. If you put n equal to 1, the n square minus 3n plus 2 term would be 0, no? Correct? And in the A augmented B, you will get the last row as full zeros. Okay? So then you'll have only 2 non-zero rows. So rank of A augmented B would be 2 in that case. Clear? In second row. But it would be non-zero, no? So you'll have at least one 2 by 2 minor, correct? You'll have at least one 2 by 2 minor in the A augmented B such that which is non-zero. So rank of A augmented B becomes 2 in that case, which is same as A. Anyway, I think you're just a bit overthinking. Just think a little calmly, you'll understand what's going on. Okay. See, for example, in the echelon form, okay, I'll explain you one more step maybe. So see here, your echelon form you got is 1 1 1 0 1 3 0 0 0 1 n minus 1 n square minus 3n plus 2. Okay. So this is the echelon form. So if you put n is equal to 1, this term is 0. So this full last row is 0. Okay. And even though this is 0, but this 1 comma 3 will make this rank 2. Okay. You can see this block, which is non-zero in this. Okay. Yeah, sometimes it happens. We just look at the simple things and feel complicated for them. It happens with me also, even many times. I look at some PDEs and all which are very easy to solve in fact, but think so much, okay, then because of which I lose the easy part of that. So just be calm, okay. Good question. Solve. I have said this question today morning. So if the letters of the word love is arranged in such a way that, because I thought that today 13th Feb will take the class, so tomorrow is some day, so I thought of putting one question with this. So if the letters of the word love is arranged in such a way that the vowels appear in alphabetical order, then the probability that E and O stay together is dash. Solve this. So what is the minimum marks in XE for IIT admission? Somewhere around 65 could be safe side. Okay, above 60 or 65 should be safe side. Okay. So tell me the answer for this. So if you arrange the letters of this word love in alphabetical order such that vowels come in alphabetical order, then the probability that E and O stay together is dash. So let's see, you have 4 words, okay? Sorry, 4 letters. So let's start with E here, or E here, and E here. Only this is what you can do, okay? You cannot put E here, because if you put E here, then O should come somewhere before. Then vowels, A, E, I, O, U are the vowels, okay? So in this, you have involvement of E and O, okay? So now if you see, these are the only 3 possibilities, okay? So here, if you fix E here in this case, then remaining 3 letters can be arranged in 3 factorial ways, okay? Because you have 3 other letters O, L and V, so you can arrange them anywhere here. Here also you can have 3 factorial ways, and here also you have 3 factorial ways. So total 18 ways is in which you can arrange such that the vowels come in alphabetical order, correct? Did you all understand this? Total there are 18 ways. 0. Hindu is very anti, I think it's okay, but there is some answer. So let's see, this is 18 ways, okay? Can you all understand it's 18? First of all, if you want to arrange this ovals, 0 is also there, no, sir? Huh? O is also there. See, but first, if you want to arrange this ovals in alphabetical order, E should take either this position or this position or this position. Correct? If you want to arrange ovals in alphabetical order, then E can take any of these 3 positions. Yes? Agreed? So total 18 ways is what you can have. Oh, sorry, this is not 3 factorial. Thank you. This is not 3 factorial, 2. This is 3 factorial, but here out of these 2 places, O can come here or here. Okay, so here either L or V should come. So there are only 2 ways in which this can fit. Okay, sorry, it's not 3 factorial. So O can come here or here. So the remaining 2 you can arrange in 2 factorial ways. So you have only 4 ways. Okay, so definitely O should come here. So here you have 2 factorial ways. So which is 2. So 6 plus 4, 10, 2, 12 ways. Sorry, yeah, correct. So there are only 12 ways. Yes, not 18. I'm sorry. So it should be only 12 ways. Yeah. I am slightly weak in this subject, so I make mistakes. Okay, so 12 ways is what you can have the ovals coming in alphabetical order. 2? Yes or no? So total ways is 12. Total ways of vowels in alphabetical order is 12. Correct? Now, out of this, the favorable cases is when you have O here, this is one case. When you have O here, that is second case, and this is the third case. So favorable cases is only 3 cases. Correct? When A takes this spot, O should take this spot. When E takes this spot, O should take this. When E takes this, O should take this. Okay, so this implies probability is 3 by 12, which is 0.25. That's why I have given round off to 2 decimal places. Perfect answer. Okay, see what I was telling you is, it is given that you have arranged the word letters in the word such that O and E cannot come, because if O comes first, okay, then O and E is not in alphabetical order. Got it? Like normally if you see the alphabetical order, O comes after E. So if you have O first, then O and E are not in alphabetical order. So that's why I'm not considering them. Okay, Vijay Sai? So Vijay Sai, tell me, is this clear to you? Like why I should not put O first? Did you get clarity? Because it's already mentioned that arranged in such a way that the vowels appear in alphabetical order. So they have already arranged the vowels in alphabetical order. Okay, so now we are considering the total cases in which vowels are in alphabetical order, and out of which E and O come together. Okay, last वाले में 2 case होगा, correct? Because if E take this spot, then O should take this spot definitely, and these two can be VL can be interchanged. So you have 2 cases. Okay, so 6 plus 4, 10 plus 2, 12. Favorable 4 होगा ना, कहाँ? Sorry, favorable should be 4. This is logged, but here sorry, did I make some cruxes here? Just a second. This is 3 factorial 2. So this is, if you have E here, you cannot have O here. So you have 2 cases in this and 2 here. So 4 is correct. So if you have E here and O here, then this is 2. So total 12 ways. This is 2 favorable cases. So it should be O here. Then these 2 can change. Correct? So 2 ways plus, in this case, these 2 can swap. So 2 ways plus these 2 can swap. So total one more 2 ways. So total 6 ways. Yeah, this is 6 and this is also 6. So 0.5. Okay. So 50% chance. Of course. It should be 6, right? Because it can have LV or VL. In these two cases, this is valid. LV, LV. So here also there are two cases. LV, VL. Here also there are two cases. So total 6. It should be 6. It's not 5, it should be 6. So it is 0.5. Yeah. Yeah, it's not 0.25, it should be 0.5. It's a good question, right? It looks very simple, but there are a lot of points in this to think. Okay, but 0.5 is the correct answer because there are two. This things can swap. Okay, the consonants are not in alphabetical order. You can interchange them. So it should be 6. 2. What you told is correct. It should be 6. So it should be 0.5. Yeah. Because consonants are not in need not be in alphabetical order. Okay, so consonants can be in any random form. Okay, so initially we got 3, but in each of the cases they can exchange and you can have 6 cases. Okay, so are you all okay with 0.5? It's fine now. Yeah, we should not think directly final steps. We should go step by step. Okay, so if you are thinking about this step, you should think about this step, not about the final answer. Good. Correct. You should not jump the steps. So one has to be careful. Okay. Fine. So let's go to the next question. If the differential equation some term dx plus some term dy is equal to 0 is exact when alpha is. Come on, it's a very simple question. So solve this. Given dE is 1 plus x square y cube plus alpha x square y square dx plus 2 plus x cube y square plus x cube y dy is equal to 0. So if this equation should be exact, then what one can do? So let's call this as some function, and this is some function x comma y actually. Okay, no more overlap. So this is m dx plus n dy. So if this has to be exact, to be an exact differential equation, I have told you one word, right? Dou m by dou y should be equal to dou n by dou x. Okay, so I have told you to remember this word Netflix always, so that you remember that this n and x combination will come together. Okay, so dou n by dou x. Then if you know one is dou n by dou x, the other is dou n by dou y. Okay, but one caution here, sometimes, in fact, I have given you in a straightforward way, but if they want to confuse you, they can give you something like n dy plus m dx is equal to 0. They'll interchange this dx and dy. Okay, because this equation, if you multiply with minus sign, you can get this form. Then people always have this habit of reading this as m dx plus n dy, and they'll do partial differentiation of this with y, which is wrong actually. Okay, the coefficient of dy should be differentiated with respect to x. That's this condition basically comes from chain rule. Okay, so which I show in all the classes. Like if you see what is the meaning of exact derivative is, this should be some derivative of some function. Then if you have dou m by dou x, dy, all these things, you will get this condition. But if you look with caution, always the coefficient of dy should be differentiated with x partially. Okay, because in this form, people take this as second function as n, but in this case the first function should be n. Okay, the coefficient of dy should be n always. So please keep this in mind. So anyway, now if you differentiate this, so this implies something is happening. Okay, so this implies m dx, so dou m by dou y, 3 y square x square plus 2 alpha x square y is equal to dou n by dou x, so 3 x square y square plus 3x square y. Okay, so this is what you have. So clearly these two terms are same. So 2 alpha should be equal to 3. So alpha should be 1.5. That's all. Okay, so one decimal place anyway. So this should be 1.5. Don't feel that these kind of questions will they come. They are very easy. There are instances where easy questions come in 𝐿𝐸. Okay. So let's see, the value of a third order determinant is 4. The value of square of the determinant formed by the cofactors will be dash. Solve this. 1 minute. Solve this question. Okay. Yeah. So solve this question. The value of a third order determinant is 4. Okay. So let A be a three-by-three matrix given det A is equal to 4. Okay. Or in fact, I'll be more precise. Okay. The value of square of the determinant found by the cofactors. So determinant of cofactor matrix is same as determinant of cofactor matrix transpose. Correct? Because you take any matrix, you take the transpose of that, the determinant should be same. But what is this matrix? Can anyone tell me? Transpose of cofactor. What should be the transpose of the cofactor? Any one of you? Adjoint. Correct? Correct? Because that of adjoint is that a whole power n minus 1 and n equal to 3 here in this case. Maybe I'll write n minus 1. So which is equal to that a square. Okay. So therefore, that of cofactor matrix found by the cofactors, which is cofactor matrix, is equal to that a whole square in this case. So obviously, if you do squaring on both sides, square of determinant found by the cofactor matrix it's an integer. Okay, so 256. Okay, adjoint. So this matrix turns out to be, the value turns out to be 256. Okay, I've told you this, no? Det of adjoint A is det a whole power n minus 1. Even in one of the PYQs, I was using this point. The more number of adjoints you have, the more number of n minus 1s you have. Like if you have 2 adjoints, then you have n minus 1 whole square. If you have 3 adjoints, n minus 1 whole cube. So that's how it turns up. Okay. Fine. So is this clear to all of you? Okay. If any one of you have any questions, then you can talk about this. Otherwise, it's okay. Chalo. Let's move to the next question. Oh, one question has jumped. What is this question? Correct, no? Okay. If x is a random variable with expectation 4 and variance 2, then the value of variance of 2x by expectation of 2x is dash. E of x is expectation and variance of x is variance of x. Okay. So let's get this answer. Given x is a random variable, okay, so x is a random variable. So expectation of x is 2, variance of x is 2. Sorry, expectation is 4. Okay, and variance is 2. So you want variance of 2x by expectation of 2x actually. So you know variance of some scalar into x is a square times variance of x, correct? And expectation of ax is equal to a times of expectation of x. So this is linear property basically. Okay. So then if you solve, okay, so this is what you get, and so 2 times variance of x, which is 2 by expectations, so which is 1. So this value should be integer, it should be 1. Okay, so these properties are a bit important, you should look at these things. So in fact I just give you some more things. Expectation of ax plus by is a into expectation of x. Normally if you have multiple variables, generally in XE you don't see these questions much, but still if they give you, it's important. Okay, and variance of ax plus by is equal to a square variance of x plus b square variance of y plus 2ab times covariance of x comma y. Okay, where covariance is expectation of xy minus expectation of x into expectation of y, but if x and y are independent things, then this covariance is 0. So you'll have this. If you take only single variable, like if you would b equal to 0 in these two, you'll get these two results, whichever I have, you know, boxed. If you put b equal to 0 in these formulas, this is what you'll end up with. Okay, fine, you can take this formulas. I'll just move aside a bit. Okay, it's fine. So let's solve this question. If phi1 of t MSQ, phi1 of t and phi2 of t are solutions of the linear differential equations, yeah, okay, let them be solutions, they can be whatever, where p of t and q of t are functions of t, then which of the following is and are also solutions of the above differential equation? So tell me, what are the correct options? So tell me, out of these things, which is the correct option? Which are the correct options, of course, whatever options. Jyoti, Yuhan, Akash, Mayank, Mechanical Rockstar, Sharma, Soya, Vibhu, Underworld, Dawn. My God, Dawn also attending the classes. Good. What are the answers? I'm waiting for your answers. Quick. B. Okay. What is the logic, Rohan? B, C. Okay. Then someone say B, C, D. Then finally I'll say A, B, C, D. Good. No. Yes. All the four are correct options. Because I have told you, for phi1 of t, phi2 of t being solutions, some constant c1 phi1 of t plus c2 phi2 of t is also a solution. While c1 comma c2 being any arbitrary constants. Okay, fine. Might be the last. I would like to thank all the teachers. Thanks. Even I say thanks from the full team, on behalf of the full team. Thank you. Meanwhile, I got some long comment in between. I have missed it accidentally. Let me scroll that comment. There's some comment, no? Yeah, this one. Hello, so I have purchased a Shreshth ESC plus GATE 2027 batch. But sir, now my mind has changed. I have to give only GATE exams because of future in AI, DRDO, ISRO. So is it okay if I will not give ESC exam? It's okay. If you want to join only ISRO and DRDO, then you need not give ESC, to be frank. Okay. Thank you, A0315. So is this clear to all of you? Like you can check, for example, okay. So d square y by dt square plus p of t into dy by dt plus q of t into y is equal to 0. Okay. So this is what you get. And you have phi 1 plus phi 2 is as the solutions. Okay. So if you put phi 1 here, y as phi 1, this is equation 1. So you multiply this full equation with c1. Okay. Since this c1 is constant, you can take this c1 inside the derivatives wherever you want. Okay. Similarly, c2 times this is equation 2. Okay. That's equation 2. So 1 plus 2 can give you, if you put this c1 here inside the derivatives and with y, similarly if you put this c2 inside the derivatives and if you add, you will understand that d square by dt square of c1 phi 1 plus c2 phi 2 plus d by dt, I mean this p of t multiplication is there, into d by dt of which means this behaves as a solution. Okay. That's why if you have two solutions, any linear combination will also be a solution. And exactly in these options, all four options are just linear combinations for c1, c2 values, for different values of c1, c2. Okay. That's you have. So let's solve this question. NAT. A box contains x black balls and x plus 18 white balls. If the probability of drawing a black ball is 2 by 5th times the probability of picking a white ball, then the number of white balls in the box is dash. Enter in integer. So let's solve this question. So you have a box. In this you have x black and x plus 18 white balls in this case. Okay. So the probability of drawing a black ball randomly. So what is the probability of drawing black ball? X by total number of balls, 2x plus 18. Okay. It's a very straightforward, easy stuff. X plus 18 by 2x plus 18. So probability of picking this. Now it's given probability of picking a black ball is 2.5 times the probability of picking a white ball. So P of B is 2 by 5 times P of W. Correct? So what does this give you? X is equal to 2 by 5 times of x plus 18, because the denominator gets cancelled on both the sides. Okay. So if you simplify this, 3x is equal to 36, x is equal to 12. Correct? I have exactly given this question because I want you to answer 12, which is the wrong answer, because x is number of black balls. Okay. But in the answer, I'm asking you number of white balls. So this is 30. Okay. I know many of you would solve this till this point and enter x is equal to 12. You'll lose marks. Okay. So that's why you should be careful. Fine. So x is 12. So this implies x plus 18 is equal to 30, and this is number of white balls. Okay. Yeah. So let's solve this. If a matrix A is equal to Aij, where Aij elements are given by I into j whole power I plus j, where I less than 1 comma j less than I, sorry, 1 less than or equal to I comma j less than or equal to 2, 3, has x1, x2, x3 as normalized eigenvectors corresponding to the distinct eigenvalues. Fantastic. Okay. So 3 distinct eigenvalues of A. Then x1, x1 transpose. So x1, x2 transpose plus x1, x3 transpose is equal to dash. Enter in integer. Come on, solve this question. The matrix is 3 by 3 size, but each element is defined by this expression. Aij is equal to I dot j whole power I plus j. Minus 1. Check again. I don't think it's minus 1. 0. No, it's not 0. If minus 1 and 0 are not the answers, then what is the answer? Always. Yeah, it should be 1. Correct? Because you see, which implies Aji is equal to j into I whole power j plus I, which is same as I into j, because this multiplication of two numbers is commutative, addition of two numbers is also commutative, so which is Aij. So this implies A is symmetric matrix. A is real symmetric matrix. Okay. So now if you take these products, so since these eigenvectors are normalized eigenvectors corresponding to distinct eigenvalues, since eigenvectors are pairwise orthogonal in this case, this is 0 and this is also 0, correct? And since these are normalized eigenvectors, this value is 1. Okay. But the good thing is, if you prepare for ESC, it would be much advantageous. Okay, Vika. But only if your goal is to go to DRDO or ISO, then you need not write ESC. But it's better always, since you have some time, and right now the LVS has also come in back into ESC services, so it's better. कल सेशन कर देंगे का? Actually आज लास्ट सेशन है, क्योंकि कल से अदर सेशंस aligned again. So मतलब किसी और बैचेस में, so I'll be able to take only today only one class. Okay, that's why yesterday I tried postponing the event by half an hour, and further thought of postponing it, but it did not work out, so I thought of doing one short session. Okay, so it's already 2 hours 40 minutes since we have started. आपका टेलीग्राम चैनल लिंक है ना यहाँ? This one. Okay, so you can just scan it, it will take you. Okay, so this is 1. So solve this complex numbers. If f of z equal to u plus iv is analytic function where u is equal to 2x times 1 minus y, the function f of z in terms of z will be dash. Can you give PDF of this class? Yeah, definitely. I'll post it in the Telegram channel. Okay. So if f of z is equal to u plus iv, u plus iv is an analytic function where u is 2x into 1 minus y, then the function f of z in terms of z will be dash. Yeah, okay, you can solve. But DRDO recently stopped conducting the exam. ISRO conducts exams, okay, but DRDO don't conduct the exams as of today. Okay, the last equipment there were descriptive exams, but this 2024 equipment, whatever they have floated, in that there is no test. Because these patterns keep changing year to year. The only thing is your knowledge is a constant. Okay, whatever the way they test it, let them test. You'll get selected if you have good knowledge. Okay, so this is the answer. Let's see. Solution. U is equal to 2x times 1 minus y. Okay, and f of z is equal to u plus iv. This is analytic. Okay, so then you can solve using this thing. Since it's analytic, this implies dou v by dou x should be same as dou v by dou y. So which implies dou v by dou y is equal to dou v by dou x, which is dou v by dou x. So 2 times of 1 minus y actually. So this implies v is equal to, but anyway, you want the function, right? Then instead of doing all this business, let's do some direct small integration so that you can get the answer using Milner-Thomson method. Okay. F dash of z into dou z by dou x is equal to dou v by dou x plus I into dou v by dou x. Okay, you differentiate it partially. So clearly this value is 1 because z is equal to x plus iy. So if you differentiate with respect to x partially, you'll get 1. So f dash of z dou u by dou x 2 times of 1 minus y plus I into this dou v by dou x is, what is this value? Minus dou u by dou y, correct? Because the 𝐂𝐤𝐴 equations. So CR equations, if you write, first if you write Cartesian, because if you're answering in XEB fluid mechanics, then it would be helpful. So dou v by dou x should be equal to dou v by dou y, and dou v by dou y should be equal to minus dou v by dou x. Okay, so this is one thing. If you write in polar, dou v by dou r is equal to 1 by r dou v by dou theta, and dou v by dou theta is equal to minus r times dou v by dou r. So these are in polar forms. Okay, so that it's advantageous if you have this too. So plus I into, anyway here Cartesian, so minus dou u by dou y, so minus 2x, that's all, correct? So this is what you should get ideally. Okay, correct now? So plus I into minus of dou u by dou y, so 2x nothing, minus 2x by, so minus 2x, yeah, 2. Now apply with the Milner-Thomson method. So by Milner-Thomson method, u plus y with 0 and x with z. So this gives you f dash of z is equal to 2 minus of minus plus I times of 2z. Okay, this is what you get. So upon integration, if you multiply dz on both sides, and if you integrate, f of z is equal to 2z plus iz square. That's all. Constant you take it to be 0 by default because no initial conditions, nothing is given. So iz square plus 2z, iz square plus 2z. B is the correct answer. Okay, this derivative involves one more minus sign. Okay, if you miss that minus, then answer becomes plus. Okay. Okay, it's B. Don't feel that I'm doing this integration, but I told complex integration is not in syllabus. Complex integration in the sense they mean about the poles, calculating residues, those stuff was not there. Okay, but this simple integration of a function can be treated as a basic calculus part. Okay. So it should be iz square plus 2z. So let's solve this. Euler's method of integration is applied to initial value problem. Dy by dx is equal to 2x, y of 0 equal to 0. If step size h is equal to 0.2, then the absolute error in computation after 5 steps means y of 1, if you calculate using Euler's method and analytical method, normal integration, then what should be the value in percentage? Okay, so that's what they're asking you. So let's solve this. So if nothing is mentioned, you can take forward Euler. Okay, so solution, dy by dx is equal to 2xy. Okay, and y of 0 is equal to 0. So if you start from 0 and with a step size of 0.2, if you go for 5 steps, then you'll get y of 1. Okay, you'll reach x is equal to 1. So what is that value? Let's see analytically. If you calculate 1 by y dy is equal to 1 by y dy is equal to 2x dx, but y of 0 is given as 0. Okay, so fine. Okay, so let's integrate this. Ln y is equal to x square plus constant. Okay, so y is equal to some constant into e power x square. This is the solution. Fine. Okay, so y is equal to some constant into e power x square, because you see y equal to e power x square plus c. So many of you may have a doubt why this is direct. Y is equal to e power x square plus c. This can be written as e power x square into e power c. So this e power c is some constant. So c into e power x square. So that's how this can be written as this. Okay. Only 2x hai sir. Kaha? Oh, y is not there. Okay, fine. Okay, so it's very simple question than what I have expected. This y is not there. Good. So it's only a function of 2x. So then if you do the simple calculation, dy is equal to 2x dx, you integrate from at x equal to 0, what is the value of y? 0. Y of 0 equal to 0. So at x is equal to 1, after 5 steps, you don't know what is the value of y. So y is equal to, okay, so y is equal to, integration of 2x is 2 into x square by 2, so it should be 1. So y of 1 is equal to 1 actually. So this is the analytical solution. Okay, so this is analytical solution. So then let's go for the Euler's technique. So Euler's method. So since nothing is mentioned, let us take back this forward Euler by default. So yi plus 1, yi plus h into f of xi yi. Okay, so this forward Euler is also called as explicit Euler. So yi plus 1 is equal to yi plus h into this function on this side is only 2x. So 2 times of xi. That's all. Okay, so yi plus 2h times xi. So let's see, since y of 0 is equal to 0, so let's apply the first step. Okay, so you march by 0.2. So y of 0.2 is equal to y of 0 plus, this is h into 2, so 2h times xi. So this is 0. So this value is 0 actually, because this term is 0 and this is also 0. Next, y of 0.4, y of 0.2 plus 2h times 0.2 actually here. Okay, then y of 0.2 is 0, but you got some value. So h is 0.2, so 0.2 into 0.2 gives you 0.04 into 2, so 0.08. That's first step. Y of 0.6, so if you simplify this, then this value has turned out to be 0.08, correct? So if you multiply this, 2 times of 0.08 plus 0.08, so 0.24. Okay, then fourth step, and this is 0.24, so 0.48, and y of 1, finally after the fifth step, first step, second, third, fourth, this is the fifth step. Okay, because if you match 5 times with a step size of 0.2, you'll get 1. So y of 0.8 plus 0.4 into 0.8 actually. So this is 0.32 and this is 0.48, so which is 0.80. So this is the estimate using the Euler's method. So therefore percentage error you get is equal to mod absolute value minus calculated value by absolute into 100, which is 20%. Okay, so 20% is the difference that you're getting if you use the Euler's technique. 20% error is what you're getting. It's a big error because 20% is like huge. So you can see we are getting only 0.8 here, but the actual solution value is 1. Okay, that's how you can say that Euler's method is not very suitable in these cases, and that's why obviously you have RK fourth order methods, all these things. Okay, because straight away the order of this Euler's method is of the order of step size, which is 0.2, which in percentage is 20. Okay, sorry, this is the question. So let's solve this. A student answers multiple choice questions with 5 alternatives, of which exactly 1 is correct. The probability that he knows the answer is P, where 0 less than P less than 1, of course. If he doesn't know the correct answer, he randomly takes one answer. Given that he has answered the question correctly, the probability that he did not take the answer randomly is dash. So can someone tell me what is the concept I can use to solve this? So कब तक लेंगे class? 12:30, okay? Some half an hour more, so that we can solve some 3-4 good questions. Okay. Fine. Some 30 minutes more. 12:30. So we'll begin the Valentine's Day with this class today. Okay. Base, correct? So let's see. Solution. Probability of when it is given correct, no guess or not guessed, you can say. Okay. Given that he you can say not a random, for example, not instead of guess, since he is ticking randomly. So not a random, given that he has answered the question correctly. Okay. Now end on high, of course. क्लास का PDF टेलीग्राम चैनल में शेयर करता हूँ, ठीक है? So let's see what is the probability of the student writing correct answer. There are 2 possibilities. Okay, so if you have correct answer, then either he knows or he randomly ticks it. And if he knows, then probability of correct answer when he knows, given that he knows the answer, this is 1. And since probability of getting correct when he randomly ticked it, it's 1/4 because it has 4 options. Correct? It has 4 options. So definitely when he randomly ticks one option, the probability that he gets the correct thing is 1/4. Okay. Okay, sorry, not 1/4, 1/5 with 5 alternatives. Okay. So this should be 1/5 because there are 5 alternatives for each question. 1/5. It's not GATE exam, some other exam maybe. So 5 alternatives. So these are the 2 ways in which he can write the correct answer. Okay. So probability of writing correct is probability of knowing and probability of writing correct when he knows. This is one case. Or probability that he randomly ticked and probability of getting correct when he randomly ticked. Okay, so that's what probability of getting the correct answer given that he randomly ticked, and probability of getting correct answer when he knows the answer. So obviously if he knows the answer, then he would definitely write it correct. So this value is 1. Okay, and probability of knowing is P. That's what they have given you. The probability that he knows the correct answer is P. Okay, if that's the probability, P into 1 plus if probability of knowing is 1, then probability of randomly ticking is 1 minus p, because he anyhow decided to write the answer. Okay, and it is 1 minus p. Now probability of getting that randomly ticked answer correct is, there are 5 alternatives, so definitely only one of them is correct. So 1 by 5. So if you simplify this, 5p plus 1 minus p by 5, so 4p plus 1 divided by 5. So this is the total probability for which he can get the answer correct. Yes, is this okay to all of you? He can answer this in 2 ways. Okay, one, either he knows the answer and definitely the answer becomes correct, or he guesses it and then the guess becomes correct. There are 2 possibilities. Okay, and these are the 2 possibilities which gives you this for the total probability of getting the correct answer. Now if you see, probability of getting, given that it is correct, he did not he did not tick the answer randomly, means the probability that he knows the answer. Okay, so this is what you need. This is reverse of this. Okay, but here this is the main event and this is the possibility, so we go for Bayes theorem. So this is, if you write the total probability, which is 4p plus 1 by 5, and these are the 2 cases. Okay, so this is the case, let me write one more step, p into 1 plus 1 minus p into 1 by 5. So this is one case and this is another case. Out of these 2 cases, the case in which he actually knows is this p. So put this on the top. That's all. This is Bayes theorem, correct? So if you simplify, 5p by 4p plus 1. That's all. So this is the actual case. So many love symbols. Thank you. Is it 12 o'clock? No. Okay, good. 5p by 4p plus 1. It's in option C. Okay. Fine. Is this okay to all of you? Come on guys, type it in the chat box. Is this fine? Yes. We'll do one thing. Rather than solving these questions in line, I'll solve some nice questions or tough questions basically. This question I have given in the rankers test. Do any of you remember? In the rankers test for mechanic, in the rankers test maths, I have given this question. We'll solve 2 questions more. Okay. So this is one question and we'll solve another good question anyway. So let's see. Alpha, beta, gamma belongs to real numbers. Okay. So if alpha, beta, gamma belongs to real numbers, A is this and B is this. Trace of A is same as trace of B. Then what is the value of this? I have formed this question for the rankers test actually. Okay. It's a good question. Come on, solve this. I'll give you 1 minute time. So anyone with the answer? Chalo, let's see. Trace of A is equal to trace of B. Okay. So this gives you alpha square plus beta square plus gamma square should be equal to 2 alpha plus 2 beta plus 2 gamma minus 3. Okay. So if you shift these terms here, alpha minus 1 whole square, beta minus 1 whole square plus gamma minus 1 whole square is equal to 0. That's all. Okay, because you see, you can shift this 2 alpha, 2 beta, 2 gamma terms to the left, and this minus 3 becomes plus 3. You can adjust that as 3 ones, 1 plus 1 plus 1. That's all. Okay, so if this alpha, beta, gamma are real numbers, and if this has to be 0, then definitely this has to be 0, this has to be 0, and this also has to be 0. So this gives you, that's all. Okay, so if you take inverses, they are also 1, so this is 3. Okay, fine. So this is how you have the things. So basically if you equate the test, this there should be 0. Okay, so is this clear to all of you? This is a small manipulation question, in fact. Okay, so let me look for one last nice question today. All this Lagrange's interpolation question. Happy Valentine's Day, sir. Thanks. Thank you all. This is the last YouTube session that I'm taking before GATE 2025, I think. So yeah, we'll remember this for some long time. Okay. Chalo. Okay, so solve this question using Lagrange's interpolation. So solve this question. I'll give you 1 minute time maybe. Or no, 1 minute is not sufficient. I'll give 2 minutes. Okay. The root of the equation f of x is equal to 0 evaluated using Lagrange's interpolation is dash. Root is not evaluated interpolatedly where f of x is evaluated using Lagrange's interpolation is dash. Okay, better. This is one last question we'll solve. Yeah, okay. So we'll do this question. So what is this? Lagrange's interpolation. Okay, so let's see. Solution. So basically you have 4 points. Okay, 1, 2, 3, 4. So if you are interpolating and you have 4 points, what is the degree of polynomial you can generate? Any one of you? See, you have four data points and you want to generate a polynomial. So what is the degree of the polynomial you can generate? Any one of you? It's not 4, it's 3. Okay, so third degree polynomial is what you can generate. Okay, and if you see the points are 30, 34, 38, 42, obviously. Okay, so let's see, given 4 points, this implies third degree polynomial is what you can generate. Fine, so third degree polynomial is something which you can generate. So this third degree polynomial, you can write it in fact in this way. So f of x is equal to a0 plus a1 into x minus 30 plus a2 into x minus 30 into x minus 34 plus a3 into a3 into x minus 30, x minus 34 into x minus 38. Okay, in fact, instead of doing all these things, let us take the generic term. Okay, so let us do direct thing. Okay, so you have 4 constants, right? So let's do directly. a0 plus a1x plus a2x square plus a2 x cube. So then, because if I add the constants and all, it would be much hectic again. So okay, so let's see in this case what we were talking. So a2 x cube. Okay, so first let us feed these points. So minus 30 is equal to a0 plus 30 times a1 plus 900 times a2 plus 30 cube. So 27, 1, 2, 3, correct? No, into a2. Sorry, this is a0, a1, a2, a3. This is a3 actually. Okay, I think I have just copy pasted this question from some nice practice sheet of mine. So this is a3. Okay, so this is first equation, of course. So similarly, you'll have 4 equations. Okay, so 4 equations, 4 unknowns. I'll just mention the methodology. So just see, because the calculations, I think I did not put the calculations very properly in this case. But one thing you can observe, root definitely comes between 34 and 38. Okay, because this is negative and this is positive. So root comes somewhere in between 34 and 38 actually. So I'll just give you the brief idea on how this can be done. So you'll have 4 equations with 4 unknowns. You solve them, you'll get the polynomial. Then you can apply Newton-Raphson, because you can take the initial guess as maybe 38. Okay, because you know this is 3 and this is minus 13. So this is close to 0. So let's start the initial guess as 38 and solve the equation using Newton-Raphson. Okay, I'm just giving the methodology because I think the constants are not very comfortable to do the calculation, because I would have done much better maybe in the setting this functional values. Calculations both hai na? Yeah. So let's not worry about the calculations. Okay, but did you all understand the methodology? You can just put these 4 points and get this coefficients, then you can calculate. Okay, yeah. So I'll give the methodology for this methodology. On substituting 4 points, this leads to 4 equations with 4 unknowns. Okay, linear equations. So on solving, this gives f of x. So if you equate f of x equal to 0, better you start with, आपने करा है क्वेश्चन, आई हैव डन यूजिंग सॉल्वर्स टू बी फ्रैंक. ओके, जब मैं क्वेश्चन सेट करता हूँ, सेट करने के टाइम पे मेरे पास सॉल्वर्स होगा, सो आई कैन सॉल्व 4x4 linear system solver, so I have solved directly. Okay, in fact I'll tell you one more thing. Okay, when you have the solver, I'll show you the power of solvers. Lagrange's interpolator, Lagrange interpolator relation calculator. Okay, so if you set the points, let's see. If you set the points, no, this is very nice stuff. So you have 4 points. Okay, so enter your data. So if you generate, we have 4 rows. X is 30. What are the values? 30, 34, I think, no? You have 34, 38. I'm showing the advantage of the, having the solvers. Okay, 30, 34, 38, 42. Okay, so you have 42. 42. This is how I give the data points. Then minus 30, minus 13. So this is, oh, sorry. Minus 30. So minus 30. Okay. And this is minus 13. And this is 3. And what about the last point? 18. Okay. 42 and 18. Okay. So you can use 18. Okay. So this is 18. So we don't need X value, any value. Okay. So decimal place is 8. So generate. So if you click generate, I think it's working out. So find. Please enter X value. Okay. Direct value like f of x equal to 2 without equation. No. Only interpolate table, only equation f of x. Okay. Find. Enter X value. Some random value you enter. Let's see. Let's make a guess. Since it's 34, it's minus 13, 38, it's 3. 3 is close to 0, of course. Okay. So 3 is close to 0. Let me put 37. I think 37 could be a close root. Anyway, let's see. Anyway, this no need to do. For next solution, click on the link below the ads. Okay. So 12 seconds you have to wait, but it gives you a solver. But normally I do it in MATLAB. Okay. So it's easy for me. In case of, in MATLAB and all, you have direct simulators and solvers which you can generate the polynomials. Okay. This is the polynomial. Okay. So maybe this x cube coefficient is coming very, very small. So this, we have the, normally should have the x cube terms ideally, but I think in this particular case, x cube terms are coming very small, so that it has neglected. But yeah, that's how you should have. So this is the interpolated polynomial. So if you put 37, I think the value should be very close. Okay. But whatever, in general, this is the idea you should get. So once you generate the function, you can apply the Newton-Raphson method. Okay. So maybe with this, we shall put a hold onto this. Yeah. There are some good questions which I'll leave you for practice. So finally, we were able to do this one shot. And I think all the schedules now got completed before GATE 2025. Okay. So this is the Telegram channel where you can follow. By seeing your channel, I came to know there are so many calculators. Obviously, there are many calculators, in fact. Okay. When setting the questions, many times I use these calculators, like the solvers, polynomial generators, all this stuff. But yeah. Okay. So then, thank you all. Let me have some hair also. Good hair. Okay. Okay. Fine. Okay. So I wish you all a very good luck. Definitely. Any last sessions for us? I'm taking class from my home till yesterday. I had taken home, but yesterday, there was some issue with the mic and all. So I have taken, today I came to studios. Okay. You're taking class at your home. I have answered. PDF I'll share in the Telegram channel. See you, sir, on 16th. Definitely. You answer all of our doubts with great patience. Thanks, Indu. And that's all, no? Any more questions? Yeah. Okay. So we'll meet on 16th. 16th is day after tomorrow. Today is Friday. Yeah, it's morning already. So anyway, so if you have any questions meanwhile in these 2 days, just you can put it in the Telegram channel. And last moment tips, whatever you see, like 15th night, don't do anything which excites you. Okay, so stay calm. Generally, I'm not capable of telling this, to be frank, because I myself in the rush of solving questions, I do many mistakes. Okay, like even in class you'll see like 2 into 5 something, I have it, 6 or 5 whatever. So don't do these kind of things. Okay, so be patient, be calm, and try to do things in a sequential way. Okay, it could help out. So thank you all. This session would be very special for me. Okay, so I'll remember this session for a long time. So XC paper, again, once you decide the subjects, then start solving the questions by clicking on the question paper tab, like how you have done for mechanical. But here in XC, you don't have much of the options, to be frank. Okay, so yeah, once you click on the question paper tab, I think it won't help you very much, in fact, for XC. But yeah, it definitely gives you some idea on which questions to solve first, at least. Okay, so click on question paper tab. Don't solve very randomly. And also, like when you start math, don't get panic if the paper is tough. Okay, if it's tough for you, it's tough for anyone in India. Okay, so don't worry. When you're solving maths, at least out of the 15 marks, you will easily get minimum 10 marks. The rest 5 marks you should slightly give a thought. Okay, that's all. My center is 250 kilometers far from my home. Please reach by tomorrow evening. Okay, to the center. I mean, to the city, at least where there is center, into that locality. Okay, take some hotel nearby and stay if possible, because before the exam night you should have a very good sleep. Okay, last day I'll tell you my situation. Okay, in fact, maybe this is my last YouTube session before GATE 2025, so I'm telling it openly. Last time fluids I got 35 out of 35. Okay, but Dharma, when I was writing Dharma, I have started in the last 1 hour. Okay, before that I have cleared maths, apti, fluid mechanics and all. But last time what happened was there was some hectic situations for me before the exam. Like there were some issues, and not issues, but there were some things happened because of which there was continuous I was not able to sleep properly for 3-4 days. Okay, just before the exam. So you won't even imagine, like people in the Parakram batches and all, they know what level of thermodynamics I teach them. Okay, thermodynamic relations, extremely depth. Okay, they know, like people like Indu, Maha Abhyas, these guys know how I teach thermodynamics. Okay, but to be frank guys, I'll tell you, because of that not sleeping for 3-4 days continuously, I think I scored something like 13 or 14 marks in thermodynamics. That's all. Okay, but last year, the year before that, in 2023 GATE, I scored thermo 35 out of 35. Okay, but this time I scored fluid 35 out of 35. But see, I'm telling you the level of things you can do if your mind is not stable and if your mind is not calm enough. Okay, so that's why I'll tell you again and again. So don't spend so much time on mobile or useless things in your life. Okay, I wanted to connect with you for some similarity and scaling analysis doubts of advanced fluid mechanics. You can message me personally in the Telegram channel. Okay, yeah, it's okay. I understand you're trying to design some experiments, so there's some modeling issues for you. It's okay. You can message me in the Telegram channel. Advanced fluids or CFD, anything is fine. You can just message me. Okay. Key topics must study in maths before exam. One is eigenvalues, eigenvectors, diagonalization. Okay. And then geometric multiplicity of eigenvalues, which I think I have solved one question in the previous playlist. Okay, you can see. And then calculus, normal, they'll take the questions, putting integrals here and there and all, they'll make some ticks. Okay, and differential equations, Euler-Cauchy, definitely. Probability, normal distributions, and Bayes theorem questions. Partial differential equations, heat equation, definitely, and some basic stuff. Okay, this b square minus 4ac based, like type of PD. Okay, that one. And complex calculus would be anyhow easy, no issues. Then numerical methods, Lagrange's interpolation. Okay, yeah, these things mostly. These are the topics where they ask again and again. And in future, anytime, like it's today, this is the last session of XC, so it doesn't mean that the contact between you and me gets end. Okay, so in future, anytime if you're from mechanical or civil, at least you can ask me anytime you have doubts of thermodynamics, applied thermodynamics, fluid mechanics, heat transfer, maths, you can keep texting me. Okay. because generally these are the I work in the thermal domain. To be precise, heat transfer is my research area. So if you have any issues in the fluids thermo heat transfer parts, you can just message me. Okay. But definitely I remember this session for a long time in my life. Thank you. So we'll meet sometime soon. Okay. Chalo then, take care. Bye. Good night. Sleep well tomorrow night. Don't think of anything. Whatever you get, utilize your weapons 100%. Okay. Signing off. Take care. Bye. Good night. All the best.